Hello,
Hello.
Team IAPE 34. Hello, welcome to the Global Youth Science and Technology Bowl 2021. I'm Carlos, the MC of this judging panel. This is team from United Arab Emirates, and their project title is Deaf Sound Tracker, DST. First, we would like to thank you for attending the judging online today and your efforts made in the past few months for this presentation. Today, we are glad to have Professor Sean and Dr. Punt from the University of Hong Kong. Today, we are glad, so please note that my window. Today, this window will turn into a countdown timer when the judging officially starts. You have 5 minutes to present your project with screen sharing of your PowerPoint or any other materials. And we will remind you when the time after 5 minutes, and you have to stop the presentation when the time's up. And there will be 4 minutes for the Q&A session after your presentation. Do you have any questions? Okay,
No, it's
okay for you. It's okay for you. So please share your presentation material now.
Is it clear?
Yeah, can everyone see this? See the screen? Yeah. Very good. So you may start your presentation now. Thank you and good luck.
Hello, everyone. Our project is called DST, which is an abbreviation to Deaf Sound Tracker. Our team consists of 2 main members, which is me, Mizna, and Dilyazia, and we are both from the Emirates Science Club from United Arab Emirates.
Deaf people nowadays have all kinds of facilities that help them to cooperate better with the surrounding environment. But they still face this problem, which is driving, because they are not able to hear the sounds around their vehicle, whether it's a police or an ambulance car. Moreover, worldwide, the percentage of deaf people is 5%, which is around 430 million people, according to the WHO report.
So that is why we built our project DST, an abbreviation to Deaf Sound Tracker, which is a smart system that helps the deaf stay aware of the sounds around their vehicles, as this system is based on intelligent tracker and LED screen displayer.
We aim with this project to help deaf people and people with special needs to cope with different sheets of societies and make them feel independent.
Our hypothesis for this project is that if we have used the high-tech technology microphone sensor to detect the sounds around the vehicle, then we will ensure having precise readings by the sensors for the LCD screen displayer to have right results. In addition to that, if we have placed a microcontroller and have activated it based on the microphone sound sensors readings, then we will ensure having a precise, innovative system of deaf sound tracking where all outputs are monitored.
This project aimed to achieve the UAE national agenda for supporting people of determination in the community, to achieve the UN Sustainable Development Goal number 3, good health and well-being, in addition to prevent and reduce severe injuries and avoid them, as well as increasing and making new jobs and opportunities for deaf people.
Our invention consisted of 4 main procedures. First of all, creating a small circuit where we tested different microphones and found that microphone amplifier Max 4466 was the best one because its results were accurate. And second, programming the sound sensor to accept some specific sound inputs, such as the ambulance sound, and connected with the LCD and a microcontroller in order to perform specific outcomes. And third, testing the system and ensuring having precise results where all outputs are monitored. And fourth, creating the project prototype and designing a special case for the prototype to be easily handled. And as for the project's component, we have been using several components, like for example, the Arduino Mega and some jumper wires and LCD.
And now we came to the most interesting part. How does this project work, or what is the methodology of this project? So first of all, this system that we made will be placed on a car or a watch, which could be able to detect the sounds, and based on those sounds, it will reflect on the LCD right here. So when the amplifier hears the sound, it will send a message to the Arduino that this sound had been detected, and the Arduino will classify the sound based on the storage that he has saved. So when the Arduino has like read the sound, it will reflect on the LCD. So now we'll test this prototype. So let's imagine that the ambulance car is nearby. So as you can see here, it printed out. Okay, so as you can see here, it's printed out, attention, ambulance around.
Moreover, this is also a demonstration video, as you can see after plugging it into power source. This is more clear video. And then ambulance car is on. So the screen displayer will type in attention, car is around, or ambulance is around, whatever sound storage we have inputted as an input. And as for the results presented on the screen, we have demonstrated our project into an ambulance car because our microphone was more precise on the ambulance car. Its precision is 96%.
We have studied our invention impact in decreasing accident rates caused by deaf people according to a scientific database when not using DST device in comparison to the decrease in injuring people while using DST device in driving, and found that when using this device, we are increasing the precautions of deaf people being on road.
Yes, and of course we have some recommendations, like for example, having it in more systems of the smart watches and several techniques of using it, and even a sustainable plan for promoting our project. Now, as for the challenges, we actually faced some difficulties in finding a suitable microphone amplifier, but we were able to solve this by using the Max 4466 amplifier. And also the storage we're getting, it saves the sound, so it didn't accept more sounds, but we were able to solve this one by using the C++ coding, the programming coding that helped our this challenge to get over this challenge. And in conclusion, thank you for listening.
Okay, thank you. Thank you very much for your presentation. So let's see if the judges have any questions for you.
Yes, sure.
Okay, maybe I'll start with the question. Congratulations on this wonderful project. I have two questions. The first is about the testing that you've done. You mentioned about the precision. So I would like to know, how do you test it? And so what are the procedures that are being done in your test? The second is about the analysis. You mentioned that actually, according to a scientific database, showing the efficiency of this DST device. So is that table, the result of the table, actually coming from using your device or coming from another device? Thank you very much.
Thank you. So the first question, you mentioned how did we conduct the precision. So at the Emirates Science Club, I have a friend of mine who she is deaf, and we related the time for the sensor to detect the sounds by the deaf person analyzing the sound or analyzing the text. So by relating the sound, we can know the precision. As you can see, if we can relate back to the table, the precision was 96% because it only took 2 seconds for the sound sensor to detect the sound of the ambulance and the frequency of the sound. So the precision was 96% because the false detect was so little in comparison to other sounds, like for example, the police car. And for the second question, I believe the second question was, again, what was the question?
Oh, yeah, it's about that, you compare the, deaf people having recorded a car crash according to a scientific database when not using DST device versus using DST device. So I would like to know, are the results being shown in that figure coming from the statistics of your device or from some other device?
Yes, so now the statistics we got it from a scientific database. This is the accident rates that has happened because of deaf people not being aware of the sounds around their vehicles. So this is a prediction of our device, as there's some other inventions that is similar but not equally like our device. So we compared our device and how it's efficient and impact on roads, as well as comparing with other devices that's already in the market and how our device is more efficient and more helping in the road for the deaf people. And based on that, we drew our conclusion, our predictions as a graph.
Okay, thank you.
Yazi, if you want to add something or more insights on any of the questions.
Maybe I'll ask some questions as well. Can you hear me okay?
Yes.
Yes. So you mentioned that you were comparing your device and other devices. Can you mention what are the major difference in terms of the concept between your device and other commercially available devices?
So in car systems or vehicle systems, we can see there is some sensors, like for example, the ultrasonic sensor to avoid the deaf person to bump into another other cars or other vehicles, but there is no a sensor or system that translates all of the sounds around the vehicles as visual text or visual content. So the deaf people can't hear all of the sounds around their vehicles. So they need a system that translates all of these sounds and puts as visual context or visual text. So this is the main idea of our project or our prototype.
Okay, maybe I'll ask a very quick question. So on this slide, you show a time of 2 seconds. 2 seconds can be a long time if you don't see a car and if the car hits you. Do you have any kind of scientific studies to show what is the time that is needed to minimize these accidents?
So now, according to the table, the 2 seconds is the maximum time needed to detect the sound. But also we can relate this and connect it with other sensors. Like for example, we have the ultrasonic sensor by which it can detect the distance before getting even the sound detection. So there's several sensors we can use and include it in our system to increase the efficiency and proficiency of our project.
Thank you.
Thank you very much for your presentation and participation. So let's see you tomorrow again in the activities and award ceremony. Okay, so you may leave your meeting room now. Thank you very much.
Thank you very much.
Bye-bye. Team IAPE 33. Hello. Welcome to the Global Youth Science and Technology Bowl 2021. I'm Carlos, the MC of this judging panel. This is team from Turkey, and their project title is The Effect of Nitinol and Metal Flexibility on Vehicle Reliability. So first, we would like to thank you for attending our judging online today and your efforts made in the past few months for developing this project and presentation. So today we are glad to have Professor Shom and Dr. Peng from the University of Hong Kong. Please note that my window will turn into a countdown timer when the judging officially starts. You will have 5 minutes to present your project with your screen sharing of PowerPoint or any other materials. We will remind you the time after 5 minutes, and you have to stop the presentation when the time's up. And there will be 4 minutes for the Q&A session after that. So do you understand?
Okay.
And any questions?
Yeah, it's okay, it's clear.
Okay, so please share your presentation material first.
Okay, I'm sharing the screen. Wait a second, please.
Yeah, sure. Take your time.
And this. Is it clear?
Yes, thank you very much. So you may start your presentation now. Good luck.
Okay, my name is Berfe Biçer. My name is Dilay Gökçe. Today we are going to present you the effects of metal flexibility on vehicle reliability with nitinol. You can ask your questions at the end of the presentation. And we aim to prevent loss of life and serious material damage. Due to this, we have developed our project by thinking these issues with the nitinol. First of all, we have witnessed an accident in 2018 and we are inspired from this car crash. Due to this, we developed our project. Most of the accidents results in serious material damage and people get injured or killed because of these accidents. So we have developed our project by thinking these issues and we want to cover our car with nitinol. As you can see from these graphs, the crash is up to 29% and the fatality is up to 12%. And the most important thing is economic loss up 56% in billions of dollars. I'll continue with nitinol alloy. Nitinol alloy consists of 50% nickel and 50% titanium. And today we call it a shape memory alloy. And we want to take advantage of nitinol's superelasticity, shape memory, and high impact absorbent properties. As you can see the photos, we crashed these two cars at the same speed and the same conditions. The only difference is the gray car is covered with nitinol, the car isn't covered with nitinol, and we can see the difference clearly. Let's watch our simulation. Elasticity is inversely proportional to the stiffness. In other words, the higher elasticity, the greater damage. Due to this basis, speeds from 35 to 15 are tested in the simulation. The cage stiffness and the hood stiffness of the car are taken into account. If the stiffness of the cage structure is high, the flexibility is high too. The opposite is also true. In outputs, maximum deceleration, cage crash, and the hood crash are taken into account on the exits. And also superelasticity is recoverable up to 11%. Now I will focus on another issue of the nitinol, which is the shape memory. If we apply some force on the nitinol car, it can return its original program shape because of the fact that the shape memory. And when we apply some heat on it too, as you can see from this figure 11. And now I'll continue with the advantages. One of the important features is that nitinol is economical and more durable, long-lasting than other alloys. Design filling elements with A1CYC. Actually, in this graph, you can see a clear artistic phase of the nitinol and the austenitic phase of the nitinol, and stretching areas and the pressure areas too in this RQO model. Now I want to talk about how we apply to this our cars. We have decided to make coating with magnetron sputtering vacuum coating machine and spraying with a chemical solution as another option too. You can see these photos. This is a magnetron sputtering vacuum coating machine. As I said before, nitrile consists of 50% nickel, and nickel can cause allergic reactions if it contacts with the complex human body. That's why we have a suggestion, and we have decided to coat our nitinol with copper by electrolysis method. As you can see the pictures. It was announced that there are 1.3 billion motor vehicles in the world in 2018. And 2021, this figure is estimated to approach 2 billion vehicles. Based on this, we say that our company will cost between $75 and $150, considering that the weight of nitinol is $15. And profit and that 5 to 10 kilograms should be used depending on the size of the vehicle. If our cost is a maximum of $150 per vehicle, it will be sold to in vehicles $170 with 10% profitability. In conclusion, this project has a property of being in the first in literature. Furthermore, it's our national and domestic technology product, and we think that it clearly shows the importance of human life, which we attach. And the nitinol coating reduces vehicle damage by a minimum of 40%. It's too important. As a result, it has been observed that it provides serious advantages as it minimizes the damage caused by loss of life and the property.
Thank you. Thank you very much for your presentation. So let's see if the judges have any questions for you.
So maybe I'll start with the first question. Is it okay?
But we cannot hear actually very well. Can you
hear me okay now? Hello?
Yes. Yes, we can.
Great. So thanks for bringing this very fascinating idea of using a nitinol. Can you share a little bit when you say you use the nitinol as the material? Do you use it for all parts of the cars, or are you thinking about only a certain part of the car? And if so, which part is the most critical?
Actually, the exoskeleton of our cars, not the inside, it's the outside. Yeah. Because due to the high impact absorbent.
I see. So only the outside, so the entire frame of the car on the outside.
Yes. Yes.
Okay. And you showed some kind of advantages of nitinol, but do you have some kind of quantitative comparison of the materials properties of this nitinol with other materials that are being used to make the same part right now?
You mentioned other alloys, right?
Yes.
As I said in the presentation, nitinol material is more durable and long-lasting than other alloys, and also quite during usage. And it's, as I said before, it's more economical than the other alloys. It's cheaper than the others. We choose that one, because of these issues and properties too.
I see. Because if this nitinol is cheaper and better, then I would imagine that the car manufacturers would be rushing to use it. So is there any reason why they are not currently using it, and maybe some advantages of the current materials that cannot be overcome by nitinol yet?
Actually, I'm stated in this report and our presentation is our project is a property of being in the first in literature. It's the first project. Yeah, also domestic technology. So it's not occurred yet in the world, we can say.
Thank you. I'll let our other judge to ask his questions. Thank you.
Okay. Thank you. Thank you too.
Hey, thank you, and congratulations again on the wonderful work. I'm just curious a little bit about exactly what you do. So, for example, you've shown some very nice simulations of some of the material properties of nitinol. I'm just curious, do you actually write the simulation program, or what kind of supports that you have in completing this work, in doing this kind of simulation?
Actually, we are working on it right now because of the pandemic conditions. We hadn't had so much resources to make it real. Now, that's why we use the simulation. It's for now, but it will be developed soon. The pandemic problems, that's why.
So is the program that you use developed by someone else, or you develop it from yourself from scratch? Just curious about it. Yeah.
Actually, we had done some simulation too, but we cannot show you because of the time limit. And this simulation, I prepared that, so I want to show that you too. Yeah, we compared the speed in cars. I showed you the pictures, and the one car is covered with nitinol, the other one is covered with nitinol, and we saw actually high impact absorbent property clearly with this picture. And the elasticity too is more important.
Okay. So do you get any support in doing the ANSYS software, or you guys actually learn to do it during the classroom?
Actually, we are working with the ETU teachers, and we had, my friends say the Istanbul Technical University teachers and Koç University teachers. We are working on it.
Okay, fantastic. Thank you.
We thank you for your
Thank you for your participation, and see you tomorrow again in the activities and award ceremony. So you may leave the meeting room now. Thank you very much.
Oh, thank you.
2019. Hello, welcome to the Global Youth Science and Technology Bowl 2021. I'm Carlos, the MC of this judging panel. Hello, this is Tim from Qatar, and their project title is a novel design for wind turbine to harvest air from 4 directions in urban spa. First, we would like to thank you for attending this judging online today and for your efforts made in the past few months for developing the project. So today, we are glad to have Professor Xiong and Dr. Pan from the University of Hong Kong to be the judges of this competition. So please note that my window will turn into a countdown timer when the judging officially starts. You will have 5 minutes to present your project with the screen sharing of PowerPoint or any other materials. We will remind you the time after 5 minutes, and you have to stop the presentation when the time's up. And there will be 4 minutes for the Q&A section after the presentation. So do you have any questions? Is it okay for you?
Yes.
Yes, so please share your presentation material first.
Okay.
That's nice. So everyone can.
Now can you see
my presentation? That's good. So you may start your presentation now. Good luck.
Okay. Hello. Good morning, everybody. My name is Hassan Al-Malki. Unfortunately, my friends are unable to connect at the moment. So today I'm going to present on half my group. Our project title is Developing a Wind Turbine for Urban Places to Harvest Air from Multiple Directions. Okay, in this presentation we will talk about the research problem and the idea of the research and the similar products, prototype development, result and analyzing, conclusion. We all know the importance of using renewable energy instead of fossil fuel. However, it's difficult to change among to favor renewable source, and is the wind. Is one of the most obtained source that use of wind turbine is limited because they require open spaces and such large space they need for wind turbine. Using wind turbine in urban places might be as the solution for the open places. According to the scientist conclusion, the wind speed in urban places or the city can be higher than its rural counterparts. Since the direction of the wind in urban places comes from multiple directions, changing due to the building structure, it makes it very important to have a cable system that can adapt to change wind direction. The importance of this research lays in saving land and better already obtained land. The objective. Our main objective of the research, developing scale version of the unit direction wind turbine, comparing the performance of the proposed turbine and a conventional one, developing a real size version of the proposed wind turbine. And the question is, can we make a wind turbine that can harvest the air from multiple directions and is sustainable for urban places? This is the similar product. Over the years, domination design has emerged, which contains of 3 blades. However, the domination does not necessarily mean best. The best turbine technology for a given project depends on the site, precise wind profile, and other requirements. Go to the next slide. Our design. One turbine blade at 45 angle, which make the angle of attacking 45 as well. This is expecting useful for having same effects regularly of the direction of the wind. For the testing, a small scale of the design and a conventionally wind turbine is designed and 3D printed. These will be tested in similar function to wind tunnel test. The test will be conducting from multiple directions for each fan. This is the result, and the result that we get from the testing. And now our left side, you see our results, and on the right side is the regular result, the convection turbine. Conclusion. A new design for the wind turbine was developed to harvest air from multiple directions. It is meant to be for urban place to be attacked to building and high region. And thank you.
Okay. Oh, time's up. Thank you very much for your presentation. So let's see if judges have any questions for you.
Thank you. Maybe I can start first.
Sure.
Yes.
Thank you.
So in the results and comparison that you show, that's based on a prototype that you built, right?
Which one?
In the plot, if you go to your plot, and yeah, the one before, yeah, not this one, the one before. Yes, yes. So this one, was it based on the calculation or was it based on experiments?
No, it's based of this experiment.
Okay.
See, we use the fan, and this blade. We change it between our blade and the regular blade, and we make a test by using this three test tool, and we put the wind in the different direction.
I see. Great. So when you design this turbine, what considerations did you put into it so that you come up with this particular geometry?
Yes. See, I will go to it. You mean this design, yes?
Yes. So why did you design it this way? Any particular design considerations that you have taken into account?
We designed it this way. Wait, I will go. Yes. We designed it this way so the air, when it comes from multiple direction, it will have the same efficiency. So see, when it comes the air from front, it hits a 45-degree blade and it spins. And the same protocol from every direction, from here and from back and from the left side.
I see.
A blade, a 45-degree blade.
And where did you get the inspiration to make this design, may I ask?
What? Can you repeat?
Where did you get the inspirations to make this design?
Do you mean how we get this design? How?
Yes.
Yes, we make first. We make testing. We have previous. We have two designs. The same. I think it's here. That's two, straight and the Q. We have two design. One and we test them and we see the difference and how it affects on the wind, and we choose this. It was better at 45 degree because it hits the air from all direction with the same efficiency.
Thank you. So maybe I'll let Dr. Pun to ask questions.
Okay, thank you very much. Maybe a specific question about, again, the test that you did. Very, very nice and interesting results. But can I assume that the y-axis is just a typo? Because the wind speed, I think on the left-hand side plot, it's from 10 to 600 meter per hour. On the other hand, on the right-hand side is from 0 to 100. Is it a typo, or is it really you need to have such high wind speed to get the new turbine design to develop to be useful?
No, in our design don't need a high wind, but in our reading, I don't know why it got a high wind, but it was in the same measurement. I think it was 30 meters,
Okay.
and we put the fan, this fan.
Yeah, because you probably do the same the experiment with the same fan, right?
Yes, we do it with the same fan at the same speed.
Okay, that's fine then. Okay. So now, I think, the next question is, now how would you further develop this idea to make it to be something useful, you think?
We will make it in large size. As you see, we make this small, not too much large, not large size, but it was little big comparing to this design.
What would you think be the major concern when you scale things up a little bit?
I don't know. We still don't make testing, but we hope that we make a big design and put it in urban places, such as building in urban places.
Okay, but have you, for example, checked the material how much material you need to use for this one? The conventional, yeah. Maybe you
in this design, we make a big design for testing only, and we put it outside for the wind, and we check it spins, but it need because here we use this small 3D printed pieces to attach it. So I think if we scale it big, we should find a solution how to scale it.
Okay, thank you.
Okay, thank you.
Thank you very much for your participation. So see you tomorrow again in the activities and the award ceremony. You may leave your this meeting room now. Thank you very much. Hello, team IAPE20. So, welcome to the Global Youth Science and Technology Bowl 2021. I'm Carlos, the MC of this judging panel. This is team from Qatar, and their project title is Automatic Fluid Handling Machine. So first, we would like to thank you for attending this judging online today and for your efforts made in the past few months for developing this project and presentation. So today we are glad to have Professor Shang and Dr. Pang from the University of Hong Kong to be the judges of this competition. So please note that this window will turn into a countdown timer when the judging officially starts. You will have 5 minutes to present your projects with the screen sharing of PowerPoint or any other materials. And we will remind you the time after 5 minutes, and you have to start the presentation when the time's up. And there will be 4 minutes for the Q&A session after the presentation. Do you have any questions? Okay. Okay, that's good. So please share your presentation material first. Oh, so very good. So everyone can see the PowerPoint. So you may start your presentation now. Good luck.
You need to unmute your mic. Yeah.
Okay. So please unmute your microphone.
Can you hear me?
Okay, so let's restart again. Okay. So you may start now.
Okay, thank you. Hello and good morning, everyone. My name is Fahd Al-Mamani with my colleagues Jassim Musalam and Abdullah Al-Fakhru. And today we're going to present our project titled Development of an Automated Cell Culture Machine to Reduce the Contamination of the Cell. In this presentation, we will talk about the research problem and objectives idea of the research. Research products, the prototype development results and analysis, and finally the conclusion and future recommendation. The cell culture machine, the cell culture process requires a lot of precision in order to succeed. And a study conducted by scientist Mary Kay proved that the most common source of contamination is a laboratory technician himself by breathing, hair, or even through the skin. The other source is a laboratory environment itself, due to not using necessary tools such as gloves, sleeves, and lab coats. The importance of this research is that it could provide access to the researchers around the world to better study in the anatomy of human cells and ultimately improve the lives of millions. Our main objectives in this research are to develop a mechanical way for moving syringe in X and Y axis, to develop a method for dispensing fluid accurately, to develop the related electrical circuitry, and to develop the program to achieve these movements. Now, Abdullah will talk about the idea of the research.
Hello, everyone. The idea of the research is to provide an automated, low-cost solution for cell culturing that can provide a contamination-free environment, dispensing system and monitoring with minimal human interference. This machine is one step in larger frame of work for cell culturing, and it's meant to replace human hand operation as indicated in figure 1. Upon our research, we looked for similar products. Upon our research, we looked for similar products, and we found these to be most similar. All of these systems are good substituted for the high machine. However, none of them care to provide self-sterilizing environment for cell culturing and maintaining them. Also, the accuracy of dispensing using a syringe needs more experiments with different machines and with different mechanisms. Now, my friend Jason will talk about the prototype.
Can you hear me? Okay. After my partner Abdullah speak about the similar prototype, I will talk about our prototype. First, we need to divide it to three parts: the mechanical and electrical, then software. We use 3D printer and laser cutter to make our prototype. As you can see in part A and B, in part A and B show the rods used. We use the wheel to have easy move. We use pulley and belt in photo D and C to move the gripper. The result and analysis. As you can see, this is the formula we use, and in the top you can see the theoretical. We put it and the number. After we tried, you can see our mistake from the average. First it was 40, then the average was 41. We have error by 2.4%. In conclusion, let's say in this research, a new automated cell culture machine was developed to reduce the contamination of the cell during the process. This machine can be breakthrough from small labs in poor countries and in the schools. And we hope in the future
thank you
we
for
can
presentation. So
use cell to plant it.
Okay, thank you. Time's up. Thank you very much. So let's see if the judges have any questions for you.
Thank you. Maybe I'll start with some quick questions.
Yeah, sure.
So you mentioned, I see that you have looked into the machines. Did you actually build a machine yourself, or did you only try to test certain parts of the machine? Hello, I think you need to unmute yourself first.
Yes, we built a machine. My colleague Antoine, I also had building it.
So the machine that you showed were the one that you built yourself by assembling different parts together?
Yes.
That's great.
We have the machine with us right now.
I see. That's great. And have you actually tested the use of the machine in doing the cell culture? Did you actually see some improvements of the cell culture?
No, we haven't tested it yet, but we will test it in the future.
I see. Okay. Thank you. Maybe I'll let Dr. Kun to ask more questions about that.
Thank you very much, Professor Sham. Actually, you've asked the question I am about to ask also. It's about, actually how you handle the part about coupling with the cell culture, and what do you think would be the kind of restrictions on the operation of your machine in this case? So again, maybe to unmute yourself. Yeah.
Because in our prototype, we make the head or the dropper, we can change it in how we want to use it. So you can choose whatever you want to do.
I'm sorry, I didn't hear very well.
Okay, I will show you the prototype. This is the head. This one. You can change it for for different application.
Okay. Maybe my other question is that right now you have done some tests on the error. Is there any way you think you can do to reduce this error a little bit further?
Please, okay, please unmute your microphone.
Oh, sorry, I didn't check. Okay, from the build and police, we can edit them to have better error. Sorry, my laptop was closed.
Yes, hello. Hello.
Hello, hello.
Yes, my partner was not charged. No, he will charge it. Only just a second. Speak with from my laptop.
Any question?
Now he joined from his laptop.
So are you going to show something to us?
Can you hear me?
Yeah, sure. Yeah, we can hear. We can hear. So anything you want to show us?
You can hear us?
Yes, we can hear you now.
Yes.
Okay, any question?
There's any question?
Okay, so any further question?
No more.
Okay, no, thank you. Okay, thank you very much for your participation. So see you tomorrow again in the activities and award ceremony. You can check your email for the link. Okay. So you may leave the meeting room now. Thank you very much for coming. Bye bye. 7. So hello, welcome to the Global Youth Science and Technology Bowl. And I'm Carlos, the MC of this judging panel. So this team is from Romania and their project title is Lifesaver. First, we would like to thank you for attending the judging online today and for your efforts made in the past few months for developing this project and presentation. So today, we are glad to have Professor Sean and Dr. Pang from the University of Hong Kong. Please note that this window will turn into a countdown timer when the judging officially starts. You have 5 minutes to present your project with the screen sharing of PowerPoint or other materials. We will remind you the time after 5 minutes, and you have to stop the presentation when the time's up. After that, there will be 4 minutes for the Q&A section. So do you have any questions? It's okay? Okay.
Okay. Yeah.
Yeah, okay. So please share your presentation material first.
Can you see our presentation?
Yeah, sure. We can see it.
Okay.
So you may start your presentation.
Okay, thank you. Thank you. Hello, everyone. My name is Patricia. And first of all, I would like to say that we are honored and grateful to be here and presenting our project in front of you. And second of all, I would like to present yourself my teammates, Darian, Andrei, Georgian, and Anka. Our name project is Lifesaver. So let's get started. We are multitasking from Romania. The mountain dangers. The statistics are pointing out increased wandering, mountain accidents, and the heroes involved in emergency actions. The difficulty arises when the potential victim is more difficult to locate, every second making the difference between life and death. So we got 3 different kinds of problems. The first one is the environment. This is based on the question, how can we help protect the environment and the biodiversity? The second one is the safety. How can we save ourselves in cases of avalanches or fire and other mountain incidents with the help of technology? And the last but not the least is the rescue, based on the question, how can we streamline search and rescue operations for the injured or those in danger on the mountain? So we found 2 solutions that go hand in hand. The first solution consists of an application, Lifesaver Dashboard mobile app. It is an app ecosystem. The second one is the surveillance system, an intelligent surveillance system consisting of chips equipped with drones. Lifesaver applications are fully functional and safe to use. The Android app has the capability to localize users and send their coordinates via internet or SMS when they are offline, meaning when they can get signal. App and database. We use Google Firebase DB to store all the data as it is very reliable and fast and works very well with our technology stack. Chatbot and Meteo. It also has an integrated chatbot, which can be used to help the users in a variety of situations. Its meteo section can display weather information for a lot of tourist stations. Chatbot section. In the chat section, users can talk with each other on a global chat or can use commands to showcase their location. The app also has a global map in which everyone can see help signals sent from anywhere in the world and can intervene. The awareness. Its final section is a camera powered on that can store images within the forest in a database, which could raise awareness about natural danger or illegal actions. Here we have Lifesaver Dashboard. The dashboard app is meant to make people explore the beauty of the nature and analyze mountain paths. And it can also show coordinates in a matter of seconds of an interactive map. An additional information here is that our app is fully functional for both of Windows and Linux. And moving on.
Ships and drones. The drone's role is to survey an area and send signals to the rescuers in case of calamities like avalanches or fires. The chips will be placed all over the mountains, indicating abnormal changes in temperature and other signs that could indicate something happening. These two systems will work together to make the rescuer's life easier and the hikers' life safe. Moving on, here we have the development of the drone and chip. Chip. The system will communicate with the database and the mobile application, announcing the possible risk areas for the users of the platform. The components have an estimated value of 20 euros, this making it efficient in terms of price to quality. Drone AI. We choose to use an AI development by ABM, making extensive use of their ABM Watson service. The AI is fully capable of recognizing humans in pictures or videos, thus making the use of drones very useful. The entire footage filmed by drones will be cut in frames via a script we developed. After that, it will be analyzed by the AI in a matter of seconds.
Thank you for your attention, and we really hope that you enjoyed our presentation. Now we are open to your questions, so feel free to ask anything about our project.
Thank you very much, and congratulations on the very nice presentations and work. So I have a couple of questions. So can you mention whether there are some similar or related apps or softwares that are already available in the market? That's my question number one. Question number two is I think your idea relies on the surveillance by the drones and the devices. So how often do they have to change batteries, or how do you plan to power them so that they can work continuously without too much human intervention? So those are my two first questions.
Okay, so in our country there is a company called Vodafone. It's a very, very big company, and they developed such a similar application. I've actually tested their app, and they have a few mistakes in how the app actually works, and their interface is also much worse. So I would say that our app has a few advantages, such as a better interface. It's working perfectly. We tested it a lot, and also it can work via a QR code. So you don't have to actually download the app in order to make it work.
And when we first started the project, we knew that this app existed, and we used it to see what we can improve. So what was missing from the app? That was the main idea of our project. And when we were testing, as Andrei said, there were a few mistakes in the meteo section, for example, and for that app. So this is how we improved it.
Can you repeat, please, the second question?
The second question is, how do you power the drones and the devices that you plan to deploy, and how often do you have to change the batteries?
The drones are basically made for single individual expeditions, so they have stations back at the household where they can be recharged. They're working on rechargeable batteries, so it shouldn't be a big problem recharging them. It's actually a pretty simple thing. We didn't think of a more complex idea.
And the drones, we'll have a lot of drones, and we won't be using all of them simultaneously. We'll have some charging, and so basically they're working in parallel. And we'll send half of them on the mountain to survey the area, and then when they charge, we'll send the others. They don't have to be recharged very often.
Thank you. Maybe Dr. Pun has more questions too. Thank you.
Thank you very much. And I'd like to congratulate you all again on a wonderful project. So two questions. The first one is about the app. Of course, you know, to make this useful, you need to have internet connection. but you also mentioned what happens when you don't, right? So I'm just curious, how is this transition being made, right? When you don't have the app, when you don't have you're in an environment where the internet connection is not strong, how would your app be useful? So that's the first question. The second question is, I'm just curious to see, how do you actualize the? Is there any demonstration you can show us? Maybe that your drone at work and along with the AI at work, so being able to identify people or whatever. So I'm just curious whether you have prepared any demonstrations. Thank you.
Okay. Okay, so for the time expired.
Oh, all right. Sorry about that.
Yeah.
Just quickly, maybe just a demonstration part then. I'd just like to see if do you have prepare any demonstration?
We developed a script that basically cuts the entire footage of the drone in frames, and they are individually analyzed by the AI. I don't have right now footage of the drone, but it totally works. We tested it before. I just deleted the footages.
Because I noticed there's a photo gallery. I'm sorry, I haven't got a chance to open it and check out in detail. So maybe we'll do that later then. Okay, thank you.
Thank you, Tom.
Thank you, Tom.
Thank you.
Thank you very much for all of you. So see you tomorrow again in the activities and award ceremony. You may leave the meeting room now. Thank you very much. Okay, so welcome to the Global Youth Science and Technology Bowl 2021. I'm Carlos, the MC of this judging panel. This is the team from Qatar, and his project title is Ice Trekking Powered Wheelchair.
Yes.
Today, we are glad to have Professor Shum and Dr. Punt from the University of Hong Kong. So thank you very much for attending this judging online today, and thanks for your efforts made in the past few months for developing this project and presentation. So please note that this window will turn into a countdown timer when the judging officially starts. You will have 5 minutes to present your project with the screen sharing of PowerPoints or any other materials. And you'll be reminded that there are 5 minutes, after 5 minutes, and you have to stop presentation when the time is up. And after that, there will be 4 minutes for Q&A sections. So do you have any problem?
No.
Any questions? Okay. So please share your presentation material first.
Can you guys see my screen?
Yeah, sure. Very clear. So if everyone is ready, so you may start your presentation now. Good luck.
Okay. So my project is a gaze-controlled wheelchair, also known as the iTrack Power Wheelchair. So what is the problem? Well, the problem is that disabled people in our community are often neglected. One, they cannot move freely, and so they cannot do the simple tasks that we normal humans can do. And that really saddens me, because just because they were born this way or got into an accident, we've just shoved them to the side and have done nothing to help them. In fact, there hasn't been a progress made in years in the field of disabilities, especially neck down paralysis, which means that you can't move your body from the neck down. They also can't live independently. And while our project won't help fix this solution, it will try to help it. So our wheelchair has two main parts. The first part is the motorized part, and the second part is the new part that separates our wheelchair from the others, and that's the communication part. Let's focus on the motorized part. So we have our eye tracking software and our wing detection all into our Raspberry Pi. And then the Raspberry Pi outputs these signals onto our Arduino Uno, which then outputs these signals onto motor drives, one that controls thrust and the other that controls the left and right movement. The Arduino also takes two inputs, one from a gyroscope sensor and one for an ultrasonic sensor for safety. So if the wheelchair flips or is about to hit something, the wheelchair will stop and then notify the caretaker. So let's focus more about the eye tracking since it's the main component. So we went through multiple iterations for the eye tracking to finally work. So we had three main iterations. The first one where we used a plain OpenCV to detect the iris and the movement of the eye. The second, we used just convolutional neural networks. And the third one, we used a combination. So our final iteration, we have a convolutional network using D-Lib's shape predictor model to mask out the whole face, except for the eyes. And then when we mask out the whole face except for the eyes, we then use OpenCV to detect the eye movement from the eyeball. And so we just see the iris and the eyeball. This is a video of the eye movement. As you can see, as I look left, the car moves left, and as I look right, the car moves right. Next up, we have our wing detection. We don't want the wheelchair to always be moving, which is why we implemented wing detection. So the wing detection will activate and deactivate the wheelchair based on a set of movements. So for example, if I wink right, then the wheelchair will activate, and if I wink left, then the wheelchair will deactivate. So for the first iteration, we used a blink sensor to detect the movement, which was fine, but it was really finicky, and you had to wear glasses and goggles, and it wasn't really comfortable. So then we decided, why don't we just use Python? We already have a built-in camera in our wheelchair. So we then use the camera, and we use something called the EAR ratio. The EAR ratio looks at the muscle tensions between the eyes here and about here, and then it just calculates how much the eye has moved. And if it has moved a certain amount in a certain period for a certain amount of time, then it considers this a wink. This is a video of the wink detection. So as you can see, as I wink, the thrust starts to activate. And then I stop. Wink again, thrust activates, and then stop. Now, what really sets us apart from any other product in the market is our communication mode. This has never been seen before and is a completely original idea. So the Raspberry Pi will take from the eye tracking code. Oh, sorry. So the Raspberry Pi takes code from the eye tracking and outputs it into a speaker, a screen, and an SMS. So we have a GUI. We use tkinter to make the GUI. It's really simple, just a couple of buttons. We then tweak the code from the eye tracking to start moving the mouse and click. And then lastly, we just plug the speakers and JSM to send messages. So what is the communication mode? So the patient will use their eyes to move the mouse onto the GUI that we've made from the screen, obviously. And from there, they can select set menus that we have, and then it will output either a sound or a speaker or an SMS to the caretaker. So let's watch the video again. So as you can see, the video is sped up, but I use my eyes to go to the speak menu, and then I say that I'm hungry, and then I'm hungry for a meal, and then sound will be output through the speaker. Thank you. Any questions?
Thank you very much for your presentation. So let's see if judges have any questions for you.
Thank you very much. My first question is, can you elaborate a little bit on the communication model, because the communication mode, because I didn't quite get how that works with the wheelchair.
Okay, so people with neck dump paralysis often can't talk or have difficulty speaking, and so the wheelchair has a screen imbued on it. And if the wheelchair is deactivated, so for example, if I wink left and the wheelchair has completely stopped, then the camera will activate, and then I can use my eyes to move the mouse. For example, this is just a GUI. I can use the mouse and then go to the set screen. So this is the main menu, okay? And so I'll use my eyes to move onto the speak, and then there are set options that we have. These options are customizable, and they can add whatever they want.
So you have to first set a set of maybe common instructions so that
exactly. So if it's the person's needs.
Great. Another question that I have is, you mentioned that you can use the eyeball movement to track and move the wheelchair and things like that. So would it be possible that sometimes the person sitting on a wheelchair will get distracted by other things and move the eyeball accidentally, and that could lead to accidents? Do you have any safety features to prevent that?
So if the eyeball moves, so if someone gets distracted, they'll obviously try to return really quickly. And our program actually doesn't register movements too quick, because so what we do is we mask the face, and then we just get the eyeballs and then the iris. And so quick movements won't do anything. What will happen is that the program will just go into sleep. And so the motors are just going to slow down for a bit and then continue.
Thank you. Maybe Dr. Pun has more questions for you. Great job.
Thank you. So congratulations also again on the wonderful project presented. I'm also interested in this idea of using eyeball movement and winking to control the wheelchair. But of course, winking is a natural human activity that you need to do, even though when you are not controlling the wheelchair. So have you thought about how you can put this into consideration?
So in the beginning, we had it set as blinking, which means just closing two eyes. But we thought that it would be too common for someone to close both eyes, which is why we've changed it to just one eye for a set amount of time. So we have it currently set as 4 seconds. So if you close your right eye for 4 seconds, that's when it will activate, and then your left eye for 2 seconds, because the activation needs to be faster.
I see. Okay, thank you. And I also noticed in your report, you say that until we reach 100% accuracy, we won't be testing our products. So I'm curious right now, what's the accuracy of this current prototype that you built? Because we've seen your demonstration. It can indeed track your eyeball movement, which is great. So right now, is it only go left or right, at the two extremes, or you actually can sort of go in between? So I'm just curious, what's the status of the prototype right now?
Yes, so the report was written a couple of months ago, and so we've obviously improved upon the project. And when the report was written, yes, it only did go to the extremes, which is why this is a video from then. Now we have more motion. It's still not fluid enough to be used in the real world, but it's fluid enough that you can, for example, go from here to your room or from here to the kitchen.
Okay, thank you very much.
Okay.
Thank you.
Thank you very much for your participation. So see you tomorrow again in the activities and award ceremony. So you may leave this meeting room now. Thank you very much for coming. Bye-bye. Hello, can you hear me? Hello, hello. Also, welcome to the Global Youth
Yes.
Science and Technology Bowl. I'm Carlos. Hello, the MC of this judging panel. So this is team from Turkey, and their project is contactless and non-destructive detection of chicken meat contamination with laser speckle method. So first of all, we would like to thank you for attending this judging honor today and your efforts made in the past few months for developing this project and presentation. So today we are glad to have Professor Shang and Dr. Pan from the University of Hong Kong. So please note that this window will turn into a countdown timer when the judging officially starts. You will have 5 minutes to present your project with screen sharing of PowerPoint or any other materials. And we will remind you the time after 5 minutes, and you have to stop the presentation once the time's up. And there will be 4 minutes for the Q&A session after that. So do you have any questions?
No, thank you.
Yeah, so you have already shared your PowerPoint, so everyone can see it. So very good. So you may start your presentation now. Good luck.
Hello, I'm Asis Söder.
I'm Miraç Ertegün.
Our project is contactless and non-destructive detection of chicken meat contamination with laser speckle method. As you know, harmful microorganisms in food can cause deterioration of human health, poisoning, and in some cases even death. Therefore, detection of microorganisms in meat products is an important issue in terms of food safety and human health. There are other methods can detect the microorganism in meat products, but the high cost, equipment, and need for specialist technicians limit the widespread use of this method in the food industry.
Despite all the problems we are talking about in this study, meat products, chicken meat, especially large microorganisms that occur in laser speckle method using simple, non-destructive, non-contact, and fast way we aim to identify. Our goals for this purpose: designing measurement system, analysis of differences between samples, contrast parameter and correlation analysis of the data, improving the system.
To explain our measurements, our method. To explain our measurement system, we have designed a simple optical photo and representation you can see. We sent laser light to the chicken meat to obtain a laser speckle pattern, and thanks to the camera we connected to the computer, we displayed the lights reflected from the chicken meat as a speckle pattern on the computer screen.
As you can see in the circuit, we use photodiode instead of cameras to observe change depending on the time, more precisely and cheaper than the camera. And we use the oscilloscope that you saw in the photo to read the data. When the camera is used in measurement system, the number of frames per second taken by the camera is limited, and on average camera of number of the frame is around 24. In this case, changes that are everyone divided by 24 seconds can be observed. The voltage change of photodiodes in light can mean nanoseconds.
In order to analyze the fresh and stale chicken meat, we took 6-second videos of laser speckle images and divided them into photo frames at 24 times per second. In the figure, you can see the speckle images of fresh and stale chicken at T0, 3, and 5 seconds. In order to see change more clearly, we selected the certain regions in the speckle pattern and examined the change of that region over time. As shown in the figure, we emit a laser beam. The lights reflected from the chicken meat, fresh chicken meat exhibits almost static motif patterns. That change slightly over time. However, the lights reflected from the stale chicken meat shows dynamic motif patterns that change a lot over time. Thus, we can detect the presence of living microorganisms by analyzing speckle patterns.
Graph of the contrast parameters of the time-dependent change is observed. In order to examine the contrast change is successive patterns. Points were determined and averaged on the graph, as shown by the red dots on the graph. You found that the contrast change in stale chicken was 3 per 1,000 on average and 1 per 1,000 in fresh chicken. This approximately threefold increase allows us to understand the difference between stale chicken and fresh chicken.
As the second method, we calculate the correlation of speckle patterns in this graph. We compare the correlation between the first photo frame and the next photo frames. According to the first photo, we saw that data is not what we wanted. That is wrong. We realized that the zigzags in correlation are more important than the correlation taken compared to the first pattern. Looking at the graph, it's seen that the stale chicken has more zigzags than the fresh chicken. That's why we decided to calculate the correlation between two consecutive photo frames.
To get a clear result, we examine the correlation between the photo and the next photo in each frame. The correlation of the change in fresh chicken in this direction, as can be seen in the graph. The maximum per 1000 is 2. So the similarity rate of two consecutive patterns is high. However, by measuring the change between the two patterns as a maximum of 7% in the stale chicken.
In this graph, you can see the time-dependent variation of the voltage value proportional to light intensity of the photodiode version we used to make our measurement system cheaper. You can see the photos in the right side. As can be seen in the graph, only 1 millivolt change are observed in fresh chicken. On stale chicken meat, you can see the big change of 10, 15 millivolts. As the speckled pattern is moving due to the movement of microorganisms. These changes prove that the chicken has started to deteriorate and that microorganism grow on it.
Result and discussions. We have designed a simple optical measurement system where we can transfer laser speckle patterns on fresh and stale chicken meat to the camera, and we examine the change in patterns.
Static speckle patterns were observed on fresh chicken meat.
Time's up. So
time's up.
Thank you for your presentation. So let's see if the judges have any questions for you. Thank you very much.
Okay.
Well, congratulations, students, on your excellent presentation. I have a question about, when you mentioned the stale chicken, and you also mentioned food safety in the beginning. So right now, is there any relation between these two? Because you can have stale chicken that is perfectly safe for people to eat.
We took this stale chicken. Sorry. Can you continue?
Yes, go ahead.
We make literature studies and we see that graph. You can see there are 8 different microorganisms can grow up in the chicken. That 2 days, there is an increase. There is a really big increase, and we see that we can took our stale chicken 2 days in 25 degrees. When we took this chicken in 25 degrees, microorganism can deteriorate easily. So we not took that chicken in fridge, not in fridge. We took these chickens in 25 degrees, room degree. The organism can deteriorate easily.
So maybe, I'm sorry, I couldn't hear everything clearly. So the stale chicken you compare to is how many days in this chart, for example? Or I'm just, I couldn't hear very clearly.
Okay, we have only 2 samples.
Yeah.
Chicken, that not weight. Stale chicken, that 2 days. 2 days in 25 degrees, room degree. Yes, 2 days. You can see the graph from our literature studies. You can see in books there are big increase in organism, 8 different microorganisms.
Okay, thank you.
You're welcome.
Another question that I have is, do you plan to do the test in a laboratory, in the market, at home, or using some handheld devices?
We make our measurements in laboratory, but you can see our suggestions. We can't add it from our presentation because it's 5 minutes. You can see our suggestions is our improved system be designed portable. Thus, it can be used in food disruption industry and storage areas in markets. We will develop our system to make it portable. But it's portable, but we have an idea. You can see there is a circuit. You can see there is jack input. When we use the jack input in our telephones, we can contact this and we can get data from cell phones. So it make our system portable.
Okay.
It's our suggestions.
Okay, another quick question is, you have done some tests on the stall meat and fresh meat, but how many times have you repeated?
Yeah.
Did you check the statistics to see if the results are statistically significant?
Yes, we make, firstly, we make from the camera, but there is three different three different findings from the three different testing. So there is one testing from the photodiode version, you can see. So we make approximately 5 tests. But also in the process, we make a lot of testing from the other measurement system, but it's our results. We have 2 different measurement systems and make 5 different testing on these measurement systems.
Okay, thank you. So in future, maybe you can consider explaining how many systems you have tested, how many different pieces of meats, and for each meat, maybe how many spots or something like that. Then it will be more comprehensive.
Yes.
Thank you. Good job.
Yes, we make it from the other meat products, liver meat, red meat, etc.
Thank you.
Thank you. Thank you for sharing. So that's all for today's presentation. So see you tomorrow again in the activities and award ceremony. You may leave the meeting room now. Thank you very much. Have a nice day. Bye-bye.
Bye-bye.
9 team. Hello, team. Can you hear me? Hello, yeah, welcome to the Global Science and Technology Bowl 2021. Yeah, I'm Carlos. Hello, I'm Carlos, the MC of this judging panel. So this team is from South Africa, and their project title is Development of a Position and Orientation Sensor for Robotics. First, we would like to thank you for attending this judging online today and for your efforts made in the past few months for this presentation and the project. So today we are glad to have Professor Shumf and Dr. Pan from the University of Hong Kong to be our judges of this competition. So please note that this window will turn into a countdown timer when the judging officially starts. You will have 5 minutes to present your project with your materials and robots, and we will remind you the time after 5 minutes, and you have to start the presentation when time's up. After that, there will be 4 minutes for the Q&A section. So do you have any questions?
All good, thank you.
Okay, thank you very much. So if everyone is ready, okay, we will, you may start your presentation now.
My name is Luke Andrews, and I would like to present my robotics position and orientation system. In robotics, one of the biggest challenges is trying to determine your robot's position and orientation on a surface. This is normally achieved using tachometers, gyroscopes, magnetometers, or even GPS. But these are influenced by external factors, such as a robot's wheel slipping, or even external magnetic fields. Usually, robots are required to follow lines and edges in order to orientate themselves. But if one could know the robot's position and orientation, you could move much faster directly to a point. I've built and programmed this prototype, which uses 2 optical computer mice in order to calculate its position and orientation in real time by combining the mice inputs with calibrations with calibration data. I've also programmed an OpenGL graphical display in order for you to see what is happening in real time. It can also be used to step back through movements that just happened using a game controller. Now on the display, you'll see there's an orange square. That is the surface, and the green block is the robot, drawn from calibrated values. On the 4 corners are blocks which change color as they represent the distance sensors and when the distance sensors go over the edge. All sensors without a fixed reference point will drift over time. I've compensated for this by integrating a set of rules into the program, which automatically adjusts its position and orientation based on known reference points, like the edges of this table. Let me demonstrate. So if I take my robot around, say to that side, you can see on the screen it is moving around, so it knows where it is. And if I turn it a bit, you'll see it also knows its orientation. Now, the second thing I'd like to show you is if I put it at a slight angle and I reset it. So now it's at an unknown position and an unknown orientation. It thinks it's in the corner over here, but in reality, it doesn't know where it is. This is to demonstrate the corrections. So as I move along, you'll see it slowly starting to adjust. Now it's adjusting the position. And as I come along this edge, the distance sensors will detect that it's an edge. And because it's a known reference point, it'll adjust the angle. Ooh, there, just adjusted. I'll keep going. Looks like it's pretty much adjusted. It's a continuous process. So the more edges you visit, the more accurate it'll be. So if I go to that edge, and then I bring it back to home base. So after starting in an unknown position and an unknown orientation, it's now corrected to know where it is relative to the surface. I would now like to demonstrate my latest prototype. If I swap screens over here, this is my latest prototype. It uses 2 ends of a Raspberry Pi camera image in order to emulate the 2 mice of my previous prototype. I wrote a new program in C in order to analyze the 2 ends of the image 850 times per second in order to detect this movement. The previous versions of this program were around 200 times too slow. However, using C, various optimizations, as well as multiple threads, it now runs in real time. The images are now only 5 centimeters apart compared to the previous prototype where they were 15 centimeters apart, but it still has the same level of accuracy. When moving from the mice to the camera, I encountered some unexpected issues. One of them was the fact that the camera has a rolling shutter, which effectively stretches the images when moving forwards and compresses them when moving backwards, which needed to be accounted for. There's also the uneven light distribution on the images. So my prototype now continuously calculates an average relative brightness for each pixel in the image and then adjusts the images accordingly. Let me demonstrate. So as you can see, if I move it around, it still works in the same way as my previous prototype, and it still knows its position as well as its orientation. The main thing about this prototype is that it is half the size compared to my previous prototype. It can also be mounted at the bottom of a moving vehicle, as it is a camera, instead of having to be dragged along the ground, like my previous prototype would have. This innovation has exciting potential in revolutionizing autonomous navigation. It has a broad variety of applications, such as in factories, where robots move parts from place to place, or even in more complicated scenarios, such as on a ship, where the surface that a robot operates on could change orientation. Thank you. Do you have any questions?
Thank you very much for your presentation. So let's see if the judges have any questions for you.
Thanks a lot. I think that's very fascinating demonstration. Congratulations. So first question I have is, what would be the maximum number of robots that you can track simultaneously using your system? If you have more than one, can you also track it?
So the way it works with the system is it's more just for tracking one single robot, but you could have multiple of these. So for example, you could have, if you're dealing with a car, you could have one camera at the back and one camera at the front, as this would give you more accuracy, but it would only be for a single robot, but you could use multiple of these systems in the robot.
I see. And what do you think? And what do you think are the spatial and temporal resolutions for this, for the tracking?
Sorry, what do you mean?
Like, for example, what is the precision in terms of the spatial precision, and and also the temporal resolution? Like, for example, how fast can the thing move and you will still be able to track it in time?
So it depends. With the accuracy, it depends on the surface. So this surface is a table, so it's got a nice grain to it, which makes it easier to track. For example, if you had a very smooth surface, then you'd have to be very close to the surface in order to detect that level of detail and to have that level of accuracy. And in terms of speed, it also depends on the surface. I reckon this is about 1.5 meters almost. And I can go pretty fast along here. But the issue, it comes in when the images don't overlap, and then you have an error in terms of them not being able to detect the movement. So it also depends on the height of the camera, because this is only 5 centimeters. So if you lifted it up, say on a gravel road where you've got more detail, or on a road, you've got more detail, you can lift it higher up, which means you can go a lot faster.
Okay, maybe I'll pass on to Dr. Pun for more questions. Thank you.
Okay, thank you very much, and congratulations for this very, very interesting demonstration. So I think I'm referring back to the first prototype that you built, because it depends on optical mouses. So that means, does it mean that there are limitations on the kind of surface that you use it? Because, you know, obviously we know how bad these mouse behave on surface like glass. So a related question, of course, therefore, is, does it only work on a homogeneous type of surface? If the surface change materials, can it still work? Because, you know, would it always treat different materials as interface? Because that's what it appears to be. So I'm just curious, how does it work in your system?
So it's limited by the mice, but I do also have the calibration.
What is about? Yeah. So the first question is about the.
Sorry.
So the first question is. Yeah.
Sorry.
Now go ahead. You answer the question. Sorry. Yeah.
Okay. So basically, I do have a calibration for it, where I basically calibrated almost to the surface. But that was one of the reasons why I decided to move on to my new prototype. Because the thing is, with the new prototype, because it continuously calculates a relative brightness for each image, it's able to adjust to different surfaces without me having to calibrate it. So for example, if I put it onto a new surface and I move it around a bit, just as long as it gets a feel for the surface, then it should work.
Mm-hmm. Okay. Yeah. So when you say you get a feel of the surface, what does it mean? What kind of surface would limit? So how smooth does it have to be, for example?
Well, it's more of being able to bring down the brightness so that it's standard between surfaces. So, for example, if you've got a very reflective surface, then it will have to adjust to it compared to something like a matte surface.
Okay, right. Thank you.
Thank you for sharing, and see you tomorrow again in the activities and award ceremony. So thank you very much for today, and you may leave the meeting room now. Thank you very much. Bye-bye. Hello, can you hear me? Hello, hello. Can you hear me? Hello. Team IBPE 09. Hello.
Sorry, we can hear you. Sorry.
Yeah, thank you very much. So welcome to the Global Youth Science and Technology Bowl 2021. I'm Carlos, the MC of this judging panel. This is team from Czech Republic, and their project title is Block Birth Zone Position in the Age Plasma of Tokamak Golem. So first, we would like to thank you very much for your attending our online judging, and thanks for your efforts made in the past few months for this presentation and the project. So today we are glad to have Professor Shum and Professor Pang from the University of Hong Kong. So please note that my windows at this window will turn into the countdown timer when the judging officially starts. You'll have 5 minutes to present your project with the screen sharing of your PowerPoint or other materials. We will remind you the time after 5 minutes, and you have to stop the presentation when the time's up. And there will be 4 minutes for the Q&A section afterwards. So do you have any questions?
No, everything's
very
clear.
good. So we have already see your presentation. Very nice. So if everyone is ready, so you may start your presentation now.
Okay, so hello, the jury, ladies and gentlemen. My name is Aleš Socha.
And my name is Simon Gurik.
And we study at Gymnázium a střední odborná škola in the town Frýdek-Místek.
We would like to present you our work entitled Position of Zone of Creation Turbulent Structures in the Edge Plasma of the Golem Tokamak. Tokamak is a device capable of creating and maintaining hot plasma in a controlled manner. In the future, fusion power plants could operate on this principle of tokamak. In the picture, you can see the Golem tokamak, on which we performed our experiments.
In the experimental part of this work, we researched in the tokamak chamber for the place of formation of turbulent structures. Turbulent structures are blobs and holes. We researched for the location of turbulent structures by measuring the radial slope profile of the ion-saturated current. The measurement took place at a distance of 90 to 37 millimeters from the center of the chamber. We used a double rake probe for the measurement.
The basic data obtained by the double rake probe were further analyzed using histograms. Histograms graphically show the distribution of values according to their frequency in the measured signal. The distribution of data in the histogram is described by skewness. If the skewness is positive, as in the case of the first image, we detect a large number of blobs in a given interval. In the case of negative slope, on the other hand, we detect a large number of holes.
The third case is a slope close to zero, which indicates an even distribution of the number of holes and blobs in a given measurement interval. By analyzing all shots whose skewness values we would compare in a single graph, we wanted to identify the place where the skewness goes from positive values through zero to negative values. We can imagine the ideal situation in this graph, in which we can distinguish three areas. In the first area, the data of positive skewness, it means blob, will be measured. In the second area, the slope will be close to zero and will smoothly move to the third area, where the negative slope will be measured. That is the holes. In such a case, the second region would determine the place of formation of turbulent structures.
Check the measure data, and also for better visualization, we created a script in Python, plotting the reconstruction of the position of the plasma and the probe in the tokamak chamber. At the same time, we based on the analysis of histogram of individual shots, we calculated data on the value of skewness, which we compared with a single graph. This graph shows the intervals of 1 millisecond, which shift through the time of the shot. The x-axis here represents the distance of the first spin from the center of the chamber, and the y-axis represents the skew value. It is possible to unify all shot data, as the plasma in all 12 shots was almost identical. We checked this based on the basic diagnostics. Reconstruction of the plasma shows that the plasma is constantly moving during the shots, and that it arises and disappears at approximately the same place in the chamber. At the same time, the probe is located almost exclusively outside the separatrix during the entire shot. The measurement values of the radial slope profile of the unsaturated current, which shows a primordially position of values, also correspond to the fact. In the measured area, blobs were mainly measured. Despite the several negative values, inclination, which were measured mainly at 14 milliseconds at the distance around 37 millimeters, the measurement suggests that the place formation of turbulent structures is located deeper inside the tokamak chamber.
Despite the unanswered hypothesis, we consider the measurement to be successful because based on the comparison of the reconstruction of the plasma position and the results of the radial slope profile, the measurement can be confirmed as a correct and corresponding theory. The benefit of this work is the information obtained through the reconstruction of the position of the plasma and the probe in the chamber, thanks to which it's possible to check the measured data and visualize the movement of the plasma in the tokamak. Another benefit is the information on the measurement of the radial slope profile on the Golem tokamak, which clearly showed the extent to which blobs are certainly located and where the location of turbulent structures is therefore not located. In future measurements, with better technical equipment, it can be directly linked to the measurement performed in this work.
Okay, time's up. Thank you very much for your presentation. So let's see if judges have any questions for you.
Of course. Thank you. Maybe I will start with the first question. May I ask, so was your study mainly based on some numerical analysis based on the algorithm that you designed? And what kind of program or software did you use to visualize these and to do the numerical work?
Well, we mostly use like we created like in Python, we created a script. We programmed this entire program and we put the data inside it. And so, yeah, we created this program for us. And yeah, but to operate tokamak, we used different programs, but it was different. But as you said, as you asked, for the data which we measured and calculated, we used Python script, which we created.
And have you tested your approach with the real test of the equipment and see whether like how accurate your results are and how much predictive power your program or algorithm has?
Well, we mostly worked with the real tokamak, so we measured this data on a true device. As was said, like we weren't 100%. We weren't able to 100% confirm our hypothesis due to technical problems, but overall we found that we found the position where these structures like became they are possible to appear, and so we will continue in our research, and we do think that we will find these turbulent structures and this place of creation. And yeah, we work with real tokamak for that.
Yeah, and did you actually get to verify what you noticed was actually the birth of the turbulence as you predicted? Because I think you need some kind of criteria to assess that in the actual system.
Well, overall, as we are measuring them, we found these changes were appearing as we inserted the probe, and yeah, we for us, we not on 100%, we need future research, but we have very strong base that we that they appear and they are real.
Okay, well, thank you. Congratulations again on the very, very interesting results on actual tokamak, which is a wonderful thing to know. So my question is, so have you compared your results with other researchers, in the research literature? Is it, typical of this time scale that these blobs are developed and the positions and the scale of these turbulence that, you see? So how do you comment on this? Because we just see a bunch of numbers. At the end, how to make sense of these numbers, I think is important. Yeah.
Well, yes, we compared them with other data on the tokamak golem, like with other research team which measured before us, and yeah, they are. we did like a deep study on this topic because altogether it was like a very, very long work. We worked around 6 months on this, so it was like yeah. But as you asked, we compared them with the data on tokamak golem, and yeah, they are very promising for the future. If it's short, okay, it's 9 seconds. Yeah. Well, thank you very much for your attention. As we said.
Thank you very much for sharing, and see you tomorrow again in the activities and award ceremony. So you may leave the meeting room now. Thank you very much for sharing.
Thank you very much. Have a great day.
Bye.
Have a nice. Hello, IAPE 30 team. So welcome to the Global Youth Science and Technology Bowl 2021. I'm Carlos, and I'm the MC of this judging panel. So this is team from Qatar, and their project title is Utilization of Humidity for Cleaning Solar Panels in Qatar. So first of all, we would like to thank you very much for attending the online judging and for your efforts made in the past few months for developing this project and presentation. So today we are glad to have Professor Shum and Dr. Peng from the University of Hong Kong to be our judges in this competition. So please note that this window, will turn into a countdown timer when the judging officially starts. You will have 5 minutes to present your project with screen sharing or of PowerPoint or any other materials. And we will remind you the time after 5 minutes, and you have to stop the presentation when the time's up. And there will be 4 minutes for Q&A session afterwards. So do you have any questions?
No, thank you.
No, thank
So
you.
good. So do you have any material to show us?
Yeah, with PowerPoint. You can share?
Yes.
Okay. Yeah, you can share.
1 minute. I will stop the PowerPoint.
Okay. Take your time.
Okay. Can you see it?
Yes. Yes. Okay. All judges can see their PowerPoint.
You can see the whole screen for the PowerPoint?
Yes. Yes. Very clear. So if everyone is ready.
1 minute.
Can we just test it?
Okay. Is it okay?
Can you see it changing?
Yeah. Yes. Yes. They are changing. Yes. Okay. Thank you very much. So you may start your presentation now.
1 minute. We think you have a problem.
Do you have any problem?
Yeah, just 1 second, bear with us, please, because we are sharing immediately from the PowerPoint. We want to share from screen 2.
Okay. Okay.
Did I stop the sharing? Wait. Okay. You can see the whole screen for the PowerPoint.
Yes.
I think you need to swap because I think now we are seeing the presenters mode, not the presentation mode.
Yes, we can. We can see your next slide.
Yes. Yes, and then swap. Right. Yeah, swap. Yes. You can see the whole screen, the whole presentation. Yes, it's perfect now.
Oh yeah, that's nice.
Okay,
Thank you. That's nice. So, are you ready?
Yeah.
Okay, you may start now. Thank you very much. Good luck.
Good morning. Thank you for giving us this opportunity to present our project. And today we will present with the title of Utilization of Humidity for Clean Solar Panels in Qatar. Okay. My name is Turki Al-Bihani, and these are my teammates, Mohammed Al-Khalifi and Mohammed Al-Badr, at the School of Qatar Science and Technology Secondary for Boys. And today, under the supervisor of Engineer Ibrahim Naim. To begin with, this is going to be our presentation outline. First of all, we're going to give an idea about what is the research problem and what is the importance of this research. Then we're going to show how we can utilize daily humidity for cleaning solar panels. After that, we're going through the steps that we have followed in order to achieve our goal. And finally, before closing with our principal outcomes and the areas of improvement, we're going to do the conclusion.
Thank you. And solar energy is one of the best and renewable suitable energy source, capturing attention day after day worldwide. And with Qatar 2030 vision, which is aiming for sustainable community, solar panels need to be clean all the time in order to maintain a higher efficiency. But most people that use solar panels face a problem, which is they have dusty surfaces. And dusty surfaces
cause a major problem, which is reduction of power supply. And so we need to clean them with water. And here in Qatar, we have limited source of water. We don't have lakes, and we barely have rains. So we need to have an automatic cleaning response to clean the solar panels. And the research is important in both the properties and solar farm scales, as it saves resources and provide a stable power supply. Yeah.
But it is always the case.
As you can see here, we do have, as my friend mentioned, we do have dusty conditions. They are dominant all the time, and we do have shortage of water, and desalination facilities are energy intensive. But but the local climate is humid around there. So we thought of using humid air as our main source of water by using the phenomenon called coalescence. So to begin with, coalescence starts with, so here's the humid air and here's the mesh. It hits it passes through the passages of the mesh, and by time it will create small droplets of water, and then they will turn into big ones, and then finally by gravity they will fall down all the way to our tank.
Wow, that's an interesting idea. But how, from where will the water come from?
Our research methodology is, and it was hard to find the resources. As our beginning, we had to search online for any similar products. And after that, we developed our initial idea and we drew a sketch for it. And with designing and 3D printing with SolidWorks and the programming with Arduino, we converted that sketch into a physical sketch, which is called prototype. And now you'll see a picture of the prototype.
As you can see here, we named it by the humidity detector. As you can see here, we have a front view and the rear view. In the front view, you can see the solar panel, and beside it, as you can see, the hoses, the yellow hoses. These are spray nozzles. And then on top of the solar panel, if you see clearly, you will notice that there is the wiper. And on top of the wiper, there is a sensor. And finally, on top of there is a fuse. I will explain later why is it important. As you can see here, we also have the rear view. In the rear view, you can see that we have the mesh, and it's connected all the way to our water tank. And then the pump. Finally, we have the most important thing that makes this that makes the humidity catcher a fully automated system. It is our programming and coding with Arduino. And finally, adding on to that, we do have, as I mentioned about the fuse, it is for a safety system, so that if the sensor does not detect the wiper, the fuse will, and it will stop it from crashing and damaging other parts of our prototype model.
Oh, thank you very much. Time's up. And let's see if the judges have any questions for you.
Thanks very much. May I start by asking whether you have done any demonstration to characterize the performance of your system, particularly in comparison with other systems that may be already commercially available?
Yeah, our projects are different because other similar products use electricity from some projects use atmospheric water generator, and that uses electricity that's from the panels, so it's consuming more electricity. But ours use the mesh to collect the water, which is no electricity needed. So ours is more.
But can you explain a bit further about the mechanism of your system, why it consumes less electricity than other systems?
Yeah, because I'll tell you from the beginning, the solar panels provide 12 voltage to the system, and Arduino only can take 5. So we reduce the voltage to the resistor, so Arduino takes 5, and the remaining voltage goes to the place that solar panels is stored like 62. So, and the electricity that the system uses only the pump and the wiper, the DC motor and the wiper. So it's not that much electricity compared to the atmospheric water generator that use more amps.
Thank you. So maybe I'll pass on to Dr. Pin for more questions.
Okay, thank you. One question I have is that, as you see, many of the solar panel a lot of times is installed at an angle. But your technique, does it involve coalescence of water? You know, when water drips down, would it affect the performance of your invention?
I don't think so. Sorry, can you repeat the question, because we not doesn't listen very properly.
Can you repeat the question?
So I'm just curious whether you have done any tests, or is there, that you've done it and a test and see if it works on maybe actual solar panels installed at an angle.
We can use it.
You want to demonstrate?
Yeah, sure. Go ahead. Yeah, if you have it ready.
Okay.
1 second, we'll just start. Sorry, but it should have started with the spray nozzles.
So how much water is needed to clean a surface like this?
Water is from humidity. It will start cleaning when there is a drop in the voltage of the solar panel, when there is dust.
I mean, how much would it be? Like a liter of water, 2 liters, or so on? So how much water is needed? Because you say it's very precious. So how much water is needed to clean a solar panel like of this size?
Yes.
About half a liter.
We use the pump, so it helps us with using less amount of water, and we just pressure it so that it goes faster and cleans better.
A little amount of water.
So very little.
Okay. Okay, that's all the question I have. Thank you.
Okay. Any more questions?
Thank you for listening.
So if no, thank you very much for your sharing, and see you tomorrow again in the activities and award ceremony. So you may leave the meeting room now. Thank you very much.
Okay.
Bye-bye. Hello, Team IAP E26. Hello, welcome to the Global Youth Science and Technology Board 2021. I'm Carlos and the MC of this judging panel. This team is from Qatar and their project title is Carbon and Dust Capture for Qatar Construction Sites. First, we would like to thank you for attending the judging online today and for your efforts made in the past few months for developing the project and presentation. So today we are glad to have Professor Sean and Dr. Pan from the University of Hong Kong. They will be our judges in this competition. And please note that this window will turn into a countdown timer when the judging officially starts. You will have 5 minutes to present your presentation with screen sharing of PowerPoint or any other materials. You will be reminded that if there is after 5 minutes and you have to stop the presentation when the time's up. After that, there will be 4 minutes for the Q&A section. So do you have any questions? So we can see the poster on the screen. So are you ready?
Yes.
So you may start now.
My name is Nasser Al-Madi and my colleague Amar Al-Badr. We are team members of Carbon and Dust Capture for Qatar Construction Sites project. So let's start about the research problem or the research question. The question is how to capture carbon and dust using a device that can be eco-friendly, portable, and cost-effective. So we came up with an idea that there is a system will capture the carbonate air and separate it by a chemical reaction. So the scientific method of our project is capturing air which consists of carbon and dust and separated by a chemical reaction using electrolyte solution.
In our electrochemical solution, there is 1 liter of distilled water, which is H2O, and 10% of potassium chloride, which will then capture the carbon particles and make them down because the carbon particles are more density than the air, so the air will go out. And then after the main idea, we started sketching it. In the beginning, we did some hand sketches and simple prototypes to check the feasibility, and we struggled in printing it because we sketched it using AutoCAD, which is SolidWorks, and then we struggled in printing it in the 3D printer because it was a little bit old.
So after finishing the prototype, we did some experiments and tests, and the result was really good. In the outlet and inlet of our project, we measured the limits of carbon concentration, and we found a huge drop in concentration of CO2. At first, the ppm was 28,000 ppm of carbon dioxide. At the outlet, it dropped to 640 ppm of carbon dioxide concentration.
And the importance of our research is to decrease the greenhouse gas emissions because they have a lot of disadvantages in our environment.
To conclude, we think that carbon and dust capture is a vital move to solve global warming.
In further explanations, we want you to see our project.
So, if you want to start the system of our project,
we have the main breaker here, as you can see. We turned on our main breaker here, and the control status turned blue, which is okay. And then we have the clean air blower, which will blow clean air from here. And inside it, we have the nano-filterization in case of there is any particle. And we have the controller speed blower here. You can control the speed. You can see here the electrochemical solution. And then here we have the electrochemical solution to start the electrochemical process. After that, we have the carbonized air fan, which will then the inlet of the carbon will be here, so it will be inside here and then go outside from here.
And everything is solar by using solar energy. And thank you for listening. If you have any question, please ask.
Okay, thank you very much for your presentation. So let's see if judges have any questions for you? Thank you.
Maybe I'll start with the first question. So can you comment on the novelty of your approach comparing with other existing approach?
Yeah, our project, the new procedure to capture carbon, and we can use the carbon after like the tank have filled. We can use it for cleaning products and or sell it to companies to use it for cleaning products in our daily life.
And our project is portable and it's small and it's easy to maintain. Other than projects, they are large and they are hard to maintain also.
And many projects like carbon capture, they use fossil fuels, and it's have a disadvantage on our environment.
I see. And in your poster, in the results, you show that there is a drop in the carbon concentrations. But have you also tested? Because I think in your project you mentioned both the carbon and dust capture. So did you also measure maybe the amount of dust, and also did you test the composition of the air after you've cleaned it using your device?
Yeah, we like used Pasco sensors to like measure the concentration of carbon, and we found a huge drop in like the concentration, and the dust will like be in the bottom of the tank, or it will be filtered from the filtration process here. So it's like you can see it's clean air.
And do you have how many of these devices, or how big of such device do you think would be needed for a typical construction site at Qatar? Because your project's objective, or in the title you say, is for the Qatar construction sites.
This is the prototype. We can make it bigger according to like the construction sites if it's huge, or the factories. So we can make it bigger, and not for Qatar, only for like for anywhere there is a high ratio of carbon emissions. So you can use it anywhere, not only Qatar.
And we can change the shape of it depending on the way you want to use it. For example, if you want to use it in construction sites, we may make it bigger, or if you want to use it in garages, so we may like a little bit smaller, depending on the way you want to use it.
Okay.
And change the orientation of the fan according to the place.
Maybe I will let Dr. Pun to ask more questions on this.
Okay, thank you. Just a short question. Congratulations on making this beautiful model. I'm just curious if what is the speed of the air that you need to, or the kind of turbulence that it would cause in the construction site area to, to actually properly collect and filter out the dust and do the carbon capture? Do you have to blow very strong wind to get the air through this cleaning system?
Now we can show you our blower speed controller, which can control the speed of the blower depending on the ratio of carbon. Like you can see here, there is from low to high.
Yeah, I'm thinking of actually applying this system, because right now you're testing it in the indoor environment of a laboratory. But if you do it on outdoor environment, when there's wind and other factors affecting your ability to capture the gas and the dust. So you probably need something to think about how you can concentrate your air input so that you can be more effective. Okay, that's all I have to say. Thank you.
Thank you.
Okay, thank you very much for sharing and participation. So see you tomorrow again in the activities and award ceremony. And you may leave the meeting room now. Thank you very much.
Thank you.
Bye-bye. EE64? Yes.
Yes.
Yeah, welcome to the Global Youth Science and Technology Bowl 2021. I'm Carlos, the MC of this judging panel. This is Tim from from South Africa, and her project title is Detection and Classification of Cardiac Arrhythmia Using Machine Learning. So first, we would like to thank you for attending this online judging and for your efforts made in the past few months for developing this project and presentation. So today we are glad to have Professor Shum and Dr. Pan from the University of Hong Kong to be our judges in this competition. So please note that this window will turn into a countdown timer when the judging officially starts. You have 5 minutes to present your project with your PowerPoint or any other materials. We'll remind you the time after 5 minutes, and you have to stop the presentation when time's up. After that, you have 4 minutes for Q&A session. Do you have any questions? Okay.
No.
Okay, very good. So please share your presentation material now.
Is it visible?
Yeah, that's great. Very good. So, are you ready?
Yes.
Okay, you may start your presentation now. Good luck.
Hello, so I'm Kavya Kaushik from South Africa, and my project was based on, as you can see, it's a detection and classification of cardiac arrhythmia using machine learning. So cardiac arrhythmia is a medical condition, which is an irregularity in the heartbeat of an individual, which is caused due to electrical signals in the heart malfunctioning. And depending on the rhythm of the arrhythmias and depending on where in the heart they occur, they're classified into different types. So how arrhythmia is diagnosed, it's a disease that affects millions of people around the world, and accurate diagnosis of this disease is therefore essential. In real life, how the diagnosis is done is by using an ECG at present, where the waveforms are presented on ECG, and doctors view this ECG to then analyze the different features of the ECG, like the P wave, mainly the QRS complex. And depending on these features, they then diagnose the type of cardiac arrhythmia and diagnose the disease accurately and take further action. So what I did for my project is that machine learning and deep learning, artificial intelligence as a whole, is something that can definitely make an impact in the field of healthcare. And for that, it can make a difference in how cardiac arrhythmia is diagnosed because of the type of data, because ECG signals is a time series data and it's got patterns. So this work is heavily based on pattern recognition, which is why using deep learning or machine learning could be essential in this field, the aim of the project was to create a model using different machine learning algorithms that would accurately classify the arrhythmia into the different types depending on the type of arrhythmia or based on the annotations. In terms of the ECG annotations, it's a P wave feature, what type of beat it is, which the doctors can then further use to classify into the type of arrhythmia. So for this project, the dataset that I used was the MIT BIH dataset, which was a very big dataset, which used about 47 subjects. This database was used about 47 subjects over 24 hours. And this data was available as raw data, which converted the analog signals to digital signals, which were then further by another data set, which was available in Kaggle, which was what this data was pre-processed. It was pre-processed by converting the data sets to a different frequency. And it was also, the waves were split into 10-second windows to further analyze the data set and convert it to a CSV format. The reason behind this being that a CSV is much easier to work with for a deep learning model, therefore making the data set much more usable with creating the model. So the method that was followed, the data was analyzed. The Kaggle data set had already split the data into the different types of categories according to the AAMI standard for classification of arrhythmias. And it had the different annotations, and as you can see on the screen. And then this data set was further split into the training data set, testing data set, the deep learning procedure, where the method for creating a deep learning model was followed, where the training data set was created, and then the model was trained using different algorithms, and this data set was then validated and you're using different techniques. So throughout this project, different techniques were analyzed. The different algorithms that were used was CNNs, random forest, XGBoost, and CatBoost. And within these algorithms, there were different aspects that were constantly analyzed and evaluated against the validation dataset to obtain what dataset provides the best optimal parameters. Once that was tested, the following results were obtained, with CNN giving us the highest accuracy, the CNN being convolutional neural networks, and random boost and XGBoost giving us the lowest accuracy. The graphs were drawn. The model worked pretty efficiently. As you can see, the training accuracy is pretty consistently growing, while the validation accuracy is definitely lower because validation dataset is the unseen dataset by the model. And the confusion matrix, everything did produce good results. In terms of the discussion, different techniques like resampling was used to balance the dataset out. Then the dataset another model was created where the dataset was only trained on 2 of the categories to see if they worked more efficiently that way. And overall, the limitations with this project is the whole deep learning. We're not sure what exact features that deep learning uses to get the output, so which is why it almost creates a black box model. So in that way, we can definitely work further into this to get a better output, and overall, this can be a huge benefit to the healthcare industry.
So thank you very much for your presentation. Time's up. And let's see if judges have any question for you.
Maybe I'll start with the first question. I noticed that because yours is a invention project, right? But I think this study, in my view, maybe is applying the AI algorithm, different AI models to analyze these different ECG signals based on the MIT BIH data set. So can you maybe clarify on the major invention that you are bringing to the table here?
Okay, so with this whole project, the thing is there's been multiple models on the internet that have tried to achieve something similar, and in different aspects, like they've worked on maybe the pre-processing aspect of this model, or they've worked on the output, which is the actual model. So in terms of all of that, the thing I specifically worked on is some of the aspects, the way the deep learning model was designed by using some of the techniques, and in terms of tuning the model and producing optimal parameters, that was something specific that I worked on, and analyzing what could be done in terms of pre-processing and stuff.
I see. And then I see that you compare different models, and then they have different accuracy, etc., right? Some of these are maybe over 96%, and others are maybe like over 98%. But in the end, I mean, these may be 2% or less than 2% difference. Can you elaborate on what you think the implications on the actual diagnosis would this difference in the accuracy lead to?
Okay, so one of the first things is, firstly, to get this model to a real-time situation, the model needs to be created in an end-to-end method, which is in terms of how the real-time data could be inputted in this model, which is an issue that I did not necessarily focus on in my project, but it is essential to how the data should be created or pre-processed automatically, so doctors in real time can use the data to feed it into this model to get a specific output. So that is with the pre-processing. In terms of the output, as I mentioned, the output deep learning produces, because it is such a complex network, we do not understand the reason behind a specific output because it's all done inside the thing. So that is a detriment to the healthcare industry. And this is something that needs to be further analyzed in terms of what exactly caused the deep learning model to produce the output. Because in healthcare, we need to know the why also, not just the what is the problem. So this is why deep learning models, what could be done is using an ensemble learning model by using an algorithm that is maybe a bit more open with what's happening inside the algorithm that could be incorporated with this. So an ensemble model is essential. And for this to be implemented in real time, the accuracy needs to be about 99%. But that is, at this point, it's mainly to create an end-to-end model, and the accuracy can eventually be achieved with a growing industry.
Okay, so we should also allow enough time for Dr. Kun to ask questions as well. Thank you. Great job.
Okay, thank you. Thank you very much. Congratulations on, I think, a very, very nice test. I'm happy to see that you actually really test the models inside out. It's a very nice investigative project. I think that's just a short question. I think in the very last sentence of your slide actually really get to me. We are talking about, you're getting data from MIT with very advanced machines, with digital machines, but you talk about the problem of an analog machine. Have you thought about what can be done if we only have analog? And the thing might have a cell phone or something. Can they still do something?
The thing is, at this moment, the signals that are used by a cell phone, the way they work is it's very simple. So it's not necessarily the accurate diagnosis we might need for such a disease, like as per saying going to a doctor. And also the analog signals is that not many places have ECG, the advanced machines. So there needs to be a way to automate analog signals to transform them automatically into digital signals to get it into a model that could do something like this. And that is definitely a field that needs to be researched.
Some kind of pattern recognition.
Yes.
So, because to wait for the signal to be digitized, that might take too long. We are talking about making quick decisions. So, just something for you to think about. Okay.
Yes, where the model can specifically look at some things as to how ECG works.
It's very easy sometimes to think about sort of first world questions and first world solutions. And I'm happy that you raised the issue of analog machines because I haven't seen them in a while, but they are there, I'm sure.
Yeah, that is something that hasn't been well investigated, and only found out later in my project of how the pre-processing is a big issue that I did not look into much.
Thank you very much.
Thank you. Thank you very much for sharing and project. So see you tomorrow again in the activities and award ceremony. So you may leave your meeting room now. Thank you very much.
Thank you.
Thank you very much.
Bye-bye.
Bye.
The Global Science and Technology Bowl 2021. I'm Carlos, the MC of this judging panel. This is Tim from Ukraine, and his project title is Investigation of Cell Oscillations in Hydrodynamic Systems. First, we would like to thank you for attending the judging online today and for your efforts made in the past few months for developing this project and presentation. So today, we are glad to have Professor Sean and Dr. Peng from the University of Hong Kong to be our judges in this competition. So please note that this window will turn into a countdown timer when the judging officially starts. You will have 5 minutes to present your project with the screen sharing or PowerPoint or any other materials. We remind you the time after 5 minutes, and you have to stop the presentation once the time's up. And there will be 4 minutes for the Q&A session afterwards. Do you have any questions?
No.
So you may share your presentation material first.
Okay.
Oh, that's great. So are you ready? Okay,
yes.
So you may start your presentation now.
Okay.
Good luck.
Okay, hello. My name is Victor Ulanov. I'd like to present my work in which I investigated properties of a hydrodynamic self-oscillation system. Safety of nuclear power plants is a major priority in a future development of a nuclear power industry. Overheating of the reactor in case of emergency is one of the main problems of water-cooled nuclear power plants. Water-cooled reactors are widespread, and they are still used for a future design of a nuclear power plants. Fukushima power plant accident in 2011 was caused by overheating of the reactor after the station blackout. Passive safety systems operated by natural forces, such as convection and gravity, are intended to use to improve their reliability. Such systems do not need external power supply, and therefore they are functional in case of station blackout. In spite of all advantages of passive systems, they have some drawbacks. Natural driving forces are quite weak, so the heat transfer of the systems is relatively slow. It may not be enough for emergency cooling. The idea of this work is to use controlled self-oscillations of two-phase water and steam coolant to improve the reliability of nuclear power plant passive safety systems or other industrial cooling systems. Nuclear power plants are very important because they have much higher power density than any other industrial systems. In the first part of our work, we considered a hermetic bottle filled with the water and a tube attached to the hole in the bottle cap. If one turns upside down, the water will start to flow out, periodically letting air in. This is self-oscillations. There are four phases of self-oscillation cycle. Firstly, water fills the tube. Then water flow out. After water rises through the tube, and finally a bubble arises, enlarges, and separates. Then the cycle repeats. To record the experimental data, we performed a recording a frequency of 120 frames per second and processed it in the Spec package. At the same time, we recorded dynamic parameters of the system, such as random pressure using Fourier multilab digital sensors. These data were processed by our own program in C++. To understand what's happening and why, we built a mathematical model of the phenomenon. For the water flow out phase, we started from the Newton's second law for water in the tube, taking into account the force of gravity, pressure, reactive force, Michels equation, and a force of internal friction. We obtained a nonlinear integral differential equations that describe dynamic of our system. For the phases of lower and raised water in the tube, we additionally took into account the force of surface tension and the boundary between water and air. We got a nonlinear differential equation. For the fourth phase, we proposed an original model of bubble formation and separation at the upper end of the tube. It is based on the theory of free submerged jet. It allows to calculate the shape and volume of bubble and thus describe one of the most complicated stages of self-oscillations. The obtained equations were solved numerically by the Runge-Kutta method of the fourth order. This is an overall good correspondence between experiment and model calculations. To study conditions of self-oscillation, we proposed a method of visualizing the system evolution on diagrams. We observed three fundamentally different types of the system behavior, which corresponds to the three zones in this diagram. We noticed that under certain conditions, the average flow rate of water during self-oscillation is greater than the rate of direct flow through the same tube. In the second part, we proposed the use of self-oscillations to improve the passive safety system performance of nuclear power plants or other industrial cooling systems. We used method and mathematical model derived for a simple system for a more complicated modeling system. We built a model installation that simulates an emergency cooling system for a nuclear reactor. It consists of two hermetic tanks connected by a short and a long tubes. The flask, used as a lower tank, gets a heat from the oil heater which regulated power up to 40 kilowatts. It corresponds to the reactor core of water boiling reactor or heat exchanger of pressurized water reactor. The heater makes the liquid in the boil. The upper tank contains a coil through which cold water flows. It corresponds to the cooling system of a nuclear power plant. We expanded the mathematical model and made numerical simulation. To the hydrodynamic part of the model, which is similar to the model described in the first part, we added the thermodynamic part, describing the heat transfer in the system. The hydrodynamic part considers the liquid and vapor flow through the tubes. As in the simple case, we proposed the use of diagrams to illustrate the total picture of the system behavior. So the main results of our work may be formulated as follows. Both the experience and the computer simulation show that the self-oscillation mode can provide more efficient heat transfer than the direct natural circulation. In the case of a reactor, an extensive heat flux from the heater we call self-oscillations, which will lead to more effective heat exchange between the heater and the cooler. In this way, critical pressure of the destruction of a reactor will not be reached, so an accident will be prevented. Obviously, to be used in real systems, this technology should be deeply studied with full-scale industrial prototype. Here you could see some references. Thanks for your attention.
Thank you very much for the very nice presentations, and congratulations on very well-conducted study. So may I ask, maybe I think you showed some comparison between your data and also your predictions. Can you maybe elaborate a bit on maybe both the static and dynamic aspects of the comparison, and tell us a little bit about how accurate is your model in predicting the static and the dynamic properties, and whether, for example, like some of these things like the bubble formation frequencies and also maybe even possibly the size of the bubble, like how accurate can your model predict those?
Okay, so you mean the second part or the first, or in whole?
As a whole.
Okay, so my model was accurate enough. And if we talk about bubble formation or about phases due to during one period of oscillations, the model was accurate enough. And in the statistics, it was the same in plus minus maximum of 5%. But in a whole. If we talk about whole periods, so not during one oscillation, but during thousands of oscillations, it also predicts the behavior. And in absolute most of cases, when we don't talk about critical cases with very small, very low pressures, or critical cases where there's no liquid in the upper container, it also corresponds very good, as you could see. Here it is statistical value, so it is values that show the experimental value that show the pressure at some power of heater after some very large period of time, like 1 hour. It don't change because it is a static value, and in the first part, of course, always there was it wasn't very large difference between model and experimental calculation, and we made at least 10 experiments for each point of these diagrams. And if we don't talk about critical values of situations when it is at the boundary between two zones, there could be some differences, but in whole, these diagrams allow us to predict the behavior. And as you could see, in whole, these second diagrams have much larger values of parameters of heater, so we could make heater power up to 1,800 kilowatts, and without self-oscillations also below 1,200 kilowatts. And we checked, of course, this experimentally, because we made a lot of graphs like this one with other parameters of the system.
Dr. Poon, please. Sorry about the.
Oh, it's okay. No, actually, I'm happy that you asked this. I think the validity of the equations, I think it's always something of concern. In particular, because you are not constructing a simple geometry system. Right? With all these different interfaces, different sizes, it's not clear whether the equations you set up properly handle all these different boundary conditions. So that's my main concern. Anyway, I think I have since during the time, I think I don't have any particular questions. Congratulations on a very nice job done. Thank you.
Thanks.
Thank you very much for your sharing and participation. So see you tomorrow again in the activities and award ceremony. So you may leave the meeting room now. Thank you very much. Bye-bye.
Also.
Hello, can you hear me? Hello, team IAPE 42. Hello, welcome to the Global Youth Science and Technology Bowl 2021. I'm Carlos, the MC of this judging panel. So this is Tim from Ireland, and his project title is using machine learning to improve numerical weather prediction. So first, we would like to thank for attending this judging online today and your efforts made in the past few months for developing this project and presentation. So we are glad to have Professor Xiong and Dr. Pan from the University of Hong Kong to be our judges in this competition. So please note that my window, this window will turn into a countdown timer when the judging officially starts. You will have 5 minutes to present your project with the screen sharing of PowerPoint or any other materials. We will remind you the time after 5 minutes, and you have to stop the presentation when the time's up. After that, you have 4 minutes for the Q&A sessions. So do you have any questions?
No, I'm good, okay. Thanks.
Yeah, so please share your presentation material first.
Yeah. Can you see my screen?
Yeah. Okay, that's great. Right? Yes, very clear. So are ready? Okay, you may start your presentation now. Good luck.
So hello, my name is Conor Casey. I'm from Public School in Invershgana in Kenmare, County Kerry, Ireland. My project is about using machine learning to improve weather prediction. So weather prediction has traditionally been done by physical models of the atmosphere, which are unstable to perturbations. Even the best simulators are often inaccurate due to insufficient knowledge of or difficulty in approximating the underlying parameters. An attractive alternative to traditional simulators is EU neural networks that train simulators directly from observational data, as this approach does not suffer from the same limitations. Another advantage of this approach is that besides from the initial training of the network, it is more efficient and less computationally intensive than traditional physical models. Weather forecasting is a sequential data problem, therefore a recurrent neural network is the most suitable option for this task. The fundamental problem, however, with traditional recurrent neural networks is that they suffer from something known as short-term memory. Short-term memory is caused by something known as the vanishing gradient problem, which is also prevalent in other neural network architectures. As the recurrent neural network processes more steps, it has trouble retaining information from previous steps. So short-term memory and the vanishing gradient problem is due to the nature of back propagation. LSTMs were created as a solution to this problem. They have internal mechanisms called gates, which regulate the flow of information. Bringing this back to numerical weather prediction, this problem is different from the one-step time series forecasting problems traditionally tackled by LSTMs and RNNs, in the sense that the prediction target of the problems is a sequence which contains both like spatial and temporal structures. Although an LSTM layer has proven powerful for handling temporal correlation, it contains too much redundancies for spatial data. To address this problem, this project will use something known as a convolutional LSTM layer. So to overcome this problem, a distinguishing feature of a convolutional LSTM layer are sort of the fact that 3D tensors is that it has 3D tensors who with the last two dimensions being spatial dimensions. The convolutional LSTM determines the future state of a certain cell in the grid by the input and past states of its local neighbors. This can easily be achieved by using a convolutional operator. This formed the foundation of my model by stacking multiple layers on top of each other. So to test my hypothesis, the software was compared against the ECM WSF integrated forecasting system weather model. It was also acted as a comparison in order to understand the performance of the software. The time required to generate a forecast will also be measured. This should give an idea as to the potential advantages of using neural networks with respect to reducing the amount of computational resources required to generate a forecast. And then this will be compared against a similar model of a similar resolution, model of similar resolution to this project. The benchmarking will carry out for the year of 2019 and 2020. For benchmarking purposes, the 500 hectopascal geopotential and the 800 hectopascal temperature were chosen as the primary verification fields. And the root mean squared error was the primary metric that was considered. So the model I found in my results, I found the model is 100 times faster in comparison to a physical model of a similar resolution. The performance in terms of accuracy is roughly equivalent to physical models of a similar spatial resolution. However, the spatial awareness is still lacking. The results from my benchmark demonstrate that the machine learning can be utilized to improve the computational efficiency of numerical weather prediction and could allow for larger ensemble sizes going forward. This could provide greater certainty in the forecast produced, as well as requiring less computational resources to generate a forecast of approximately equal accuracy. So now I'm just going to share a video of an example of a forecast produced by the software. So this was produced near real time around the time when I made it, which was around in April. And so I used the initialization conditions from the American model known as the Global Forecast System. And so this is just a clip of the forecast for the next 3 days in the Northern Hemisphere, focusing on Ireland. So thank you. I'm finished with my presentation and I look forward to hearing your questions.
Thank you very much for your presentation. So let's see if the judges have any questions for you.
So I think we've lost Professor Shum. Is that?
Oh yes.
Okay. Right. Well, anyway, okay. Thank you.
Chris,
maybe I'll go first. Congratulations, a very interesting project. So, so right now, is it only for temperature prediction? Is it the model only for temperature prediction, or have you tried on other things?
So it only focuses it on, at the moment, it's only temperature and geopotential. And so the reason that I just chose them was it was more of a proof of concept. So these are generally the standard metrics used to sort of compare against different models. So that's why I focus on those two.
Okay. And how about the scale? Because right now it appears that you mentioned the scale, if I read it correctly, is 1.6 or 2.2 degree. Is that the,
yeah, it's 1.6.
So what limits this scale? Why is it? Why this scale? What's the limitation here?
So in the training process, so while it's like really fast once you have the trained model, in the training process it was quite computationally intensive to train the model initially. So obviously I don't have a lot of computational resources at my disposal. So I had to limit the resolution of the model just so I could actually sort of train it. So, but like if you had more resources, you'd definitely be able to train it on a high resolution.
Yeah, fair enough, I think. But just curious right now, so it appears it's more useful as a tool to predict sort of global temperature variations, but not a particular country or region there.
Yeah, it's a more global variation in temperature and geopotential, synoptic scale sort of stuff rather than local, like for a particular region or anything like that.
Yeah. So have you tried out other algorithms? Because you mentioned this problem of the short-term memory, so you use the long-term, short-term, fix it. But is there other algorithms that you've tested and tried?
So like when I mentioned, I had tried initially using just the recurrent neural network and the results were a bit iffy when I used that. And then I switched to an LSTM, which was quite good. But the problem was that it was even crazily computationally intensive because you had to like flatten the data, like the 2D data, so that it'll just like fit into the shape required for an LSTM. And then that's when that's kind of once I tried the LSTM, I sort of then tried the convolutional LSTM.
Thank you. So maybe I pass the time to Professor Chum.
Yes, thank you. Sorry, there was some internet connection problem early on. May I ask, so how many types of weather data have you tested this on? And do you see any kind of particular match with certain types of weather on the model, or this model, or this particular neural network would be applicable to all kinds of weather scenarios in all places?
So the two metrics I focused on for this project, just as a proof of concept, were the 500 hectopascal geopotential and the 850 hectopascal temperature. So these sort of encoded just for general synoptic scaled distribution of stuff. If you were to expand this project further and develop on it further, I think you can use something known as transfer learning. So a lot of the stuff learned from the temperature and geopotential would also be applicable to how the wind is distributed. So you could use some of that initial training from those other two metrics, and then use that sort of the weights and biases of those networks to speed up the training for other networks, and that would improve the accuracy. I don't know if that answered your question.
Yes. So I think it shows that you have thought a bit about this and show quite a bit of understanding. So congratulations on a job well done.
Thank you.
Yeah. And for someone coming from this part of the world, when we have typhoons, or I think they call it hurricanes in America, it will be fun to see how your program actually works under those sort of special weather systems.
Yeah, it would be interesting. Yeah.
Looking forward to that. Thank you.
Thank you very much for sharing. So see you tomorrow again in the activities and award ceremony. So you may leave the meeting room now. Thank you very much. Bye-bye.
Thank you.
Have a nice day. E08. So welcome to the Global Youth Science and Technology Bowl 2021. I'm Carlos, the MC of this judging panel. So this team is from South Africa, and his project is Solar Heater. So first, we would like to thank you for attending this judging online today and for your efforts made in the past few months for developing this project and presentation. So today we are glad to have Professor Shum and Dr. Pang from the University of Hong Kong to be our judges in this competition. So please note that my window will turn into a countdown timer when the judging officially starts. You have 5 minutes to present your project with the screen sharing of PowerPoint or any other materials. I will remind you the time after 5 minutes, and you have to stop the presentation when the time's up. And there will be 4 minutes for Q&A session afterwards. Okay. Do you have any questions?
No.
Oh, very good. So do you have any PowerPoint share with us? Or?
I have an MP4, a video.
Okay. So you can, are you ready now? Or you would like to share the video first?
I'd like to share the video first.
Yeah, sure.
Take your time. I'll share my screen. Okay.
Good day.
So are you ready? Okay.
A grade 10 student from Characterize, South Africa, and I'm honored to be able to present my invention to you. Heating is a basic requirement, but many third world countries still have schools without heating, water, or electricity. My project, called Soleil, is a heater, but only requires sunlight to generate temperatures up to 50 degrees Celsius. Research on renewable energy is currently important and cannot be stressed enough. It is expected by the year 2060 we will run out of coal and natural gas, and that's only 40 years from now. The idea for the design of a solar heater was to make it easy to modify, maintain, and clean. It must be as easy as just add sunlight. The design head of a solar heater consists of this, and this. Solar is easy to install and does not need gas or electricity. It uses 100% renewable energy and needs no maintenance, and is very simple to repair if necessary. It is lightweight, whilst making it portable and transparent, so it can be aesthetically used in a windowed home, office, or school, drastically improving results while keeping it affordable. The approximate cost per solar heater is $120, which is a single investment with no added maintenance costs. The testing of its efficiency of a solar heater required temperature measurements to be taken at various locations and methods. The ambient temperatures are measured and compared with the other temperatures to establish an increase of heat generated by the solar heater under different weather conditions. Whilst testing my project, we often experienced load shedding, where the electricity would be off for hours, therefore proving the need for my project once again. Here is a graph of the average temperature, and here is one showing the different types of red panels. As you can see, the darker it is, the more effective but less transparent, so it can't really be used in windows. Orientation is also important for the installation, as the school needs warm air earlier in the morning, vice facing northeast, and the office needs warmer air during the day. Thus, my conclusion is that tests conducted on the actual prototype prove that the new aluminium frame and acrylic glass will perform in the heat. The installation of the thermostat switches also control the temperature of the solar heater and provides a constant flow of fresh heated air into classrooms and offices. The current solar heater model will make it possible to blow fresh air heated from outside into the building. The commercialization of this brand new South African product can be used in schools and businesses with easy heating. Thanks for watching.
Okay, thank you for letting me show you the video. I'm now going to show you because I actually have it here behind me. Here's a box that I made to package it in, and here's the solar heater. It's a very simple design, and at the bottom here it has a solar panel. Okay, so it uses steel cores that are spray painted black to generate heat, and I have 4 layers of it. So as the sun shines onto it, it generates heat between the layers. Now, because the air becomes warm, it moves upwards. Here on top is a small fan. And when the heater becomes warm enough, the fan will go on because there's a thermostat here at the bottom with a wire going all the way up. So it will detect when it reaches a certain temperature and put the fan on and off to keep it at a certain temperature so that it doesn't become too warm and damage itself, because sometimes it will go up to 60 degrees Celsius. And you don't need it to be that warm because otherwise the room is going to become too warm. So the fan goes on when it reaches a certain temperature, and it increases the airflow, which also means that it will heat up the building quicker. It's powered with a solar panel at the bottom, and you can also see on a small screen what the temperature is. I made it with an aluminium frame that I also spray painted black, so it's very strong and it's waterproof. And I also put the handle so that you can easily move it. It doesn't need any electricity. You don't need to plug it in anywhere. You can just take it, put it down, and it will do its own thing. You don't need anything. Do any of you have any questions?
Thank you very much, and congratulations on this very interesting design. So, yes, you mentioned that this could be something that would be helpful during the COVID-19 pandemic. Could you maybe elaborate on that a bit?
Well, I've been doing a lot of research, and I've been twice overseas to Europe. And what I've noticed is it's very different from where I'm in South Africa, because it's much colder and smaller rooms, and every room uses air conditioning to keep it warm. And the problem is my father, when he goes there, it becomes too humid and too stuffy. And I did research about it, and there's actually a lot of bad things that air cons do where they recycle the air. And sometimes they can even spread certain like diseases and stuff because the filters can get dirty, and it's recycling the same air over and over. And what this is meant for is you can slide through a see-through panel at the rear, at the back behind it. So you can put it in a window and it will still be see-through. And then you'll be able to bring like cold air from outside to inside. So it's actually meant to bring fresh air, but still warm enough for a room in, instead of air cons that just recycles the same air that's inside of the room.
Great. Another question that I have is, so you obviously designed and tested the performance of this. Have you thought a bit about the cost of this? And also, I think you tested that by painting the window with different colors, that would lead to different performances. But I think for some of these buildings, people also care about the aesthetic of the window. So have you thought about these two, maybe not so scientific, but also important aspects, namely the cost and the aesthetics?
Yes, I made it out of an aluminium frame, so it's very strong and I like how it looks. I'm also painted it black, so it's slightly more effective. And I like it looks, I think it looks better black. But what you can do is, at the moment it's black. It has a rear panel that's black because it has a front one and a back one that's at the perspex. So it's like a type of plastic glass. And you can easily take it out. There's 2 screws on the top that you can unscrew. And then you can put the back panel to be completely see-through. So I think that will look better for some people. Of course, it depends on preferences. And I also looked at the cost, and I'm trying to cut down, but the biggest thing is not just the manufacturing. And how I looked at this is like spaceships, like going to the moon and stuff. In the 60s and 70s, it was so expensive, and these days Elon Musk is going up and down to the moon with the same rocket. So as you make more of it, the price will decrease. And yes, the bulk, if you buy bulk, it's also cheaper. But and another thing that I forgot to mention or elaborate on is in South Africa, we often experience something called load shedding, which is basically if I put our electricity off for a few hours a day. It depends. Some days it's only 1 hour. Some days it can be up to 3 hours at a time. There's different stages. And basically because there's a lot of things going on with electricity shortages, and it's very irritating because sometimes you don't tell you when, and a lot of people use generators to be able to power just their lights and stuff. But that's also to power a heater on a generator or solar panels is very difficult because they use a lot of electricity. So this is also very helpful for us where there isn't electricity in load shedding. And a lot of the times it does happen in the day. So it's the perfect time for this.
Well, I would like to say congratulations on the wonderful work done. And it's always nice to see an actual working model. Just a quick question. How about this issue of darkening it by 60%? This pretty severe darkening for a window. So basically, the interior will be significantly darker even during the day. So has it been actually, and you can imagine if you use it for a big scale, then the room actually will be significantly darkened. Have you been looking into this issue at all?
Yes, I have been looking at the difference between darkened and non-darkened. And if you want to darken it, of course, you won't be able to see through it anymore. So you won't be able to put it in a window, but you will still be able to put it against the wall outside and then run one of those ventilation tubes that they normally have in the roofs of very big buildings. And I tried that as well, and that also works. You can have it outside of a room as well. It doesn't have to be inside or against the window. So you can, it depends on what circumstances it is, if you want it darker or not.
Okay, thank you very much.
Okay. Is that all?
Okay, thank you for your presentation. And so see you tomorrow again in the activities and award ceremony. So you may leave the meeting room now. Thank you very much.
Okay, bye. Have a nice day.
Bye.
Thank you.
Thank you.